And in graph, you have DFS, maybe recursion. I mean, recursion is not part of graph, but that's the week where the recursion also comes. So overall, I look at city syllables at this 4 points: plain pseudocodes, list, dictionary, graph. So these 4 points will have equal distribution, a roughly equal distribution in the interim exam paper.
How many questions?
Beyond that, I cannot comment anything related to weightage, because even I don't know what exact weightage. I mean, we haven't designed paper focusing on specific weightage. This is how we have designed the paper.
Sir, how many questions we can expect, sir?
That again, I'm not sure. I mean, that's not something which we are.
What would be the duration of the exam?
That's 1.5 hours. So it will be manageable within the given time. That's something to make sure. Yes, Walter.
Submit button कब available होगा, कितने like time पे?
So that is something you have to check. I mean, usually what you tell me in 3 hours exam paper, when submit buttons gets enabled. That's something.
For half an hour.
For 1.5 hour or maybe 2 hours.
Okay, yeah, then 1.5 hours. That's how it will.
3:30, but इस बार exam तो सुबह 9 बजे से होगा.
Yeah, so 1.5 hours from that point onwards.
Oh.
It will be written on the instruction.
Yeah, it will be there on your admit card. This is something not related to the CT. So
All ticket अभी तक available नहीं हुआ है सर.
हो जाएगा भाई, हो जाएगा. थोड़ा.
They had written, they will release it on 5th of August.
Yeah, so they will release on 5th of August. थोड़ा सबर करो भाई.
Sir,
okay, then
explain today.
Yeah,
Hello.
Sukanya. Yeah, Sukanya.
Could you please explain today again the pseudocode for matrices? Because while I was doing matrices pseudocode, I got confused a lot.
Fine, sure. As I said, right,
Yes, sir.
I'm planning to do the revision of week 9 to 11. So of course, matrix concept is there, and I have prepared some very small basic slides, which if you remember, I prepared for quiz 2 also, right? The same slides
Yes,
are
sir.
actually there in week 12. Now, nothing new. The same slides I will use from week 12, but I will try to explain few things for last 3 weeks. And I believe in that most of your matrix or graph related doubts will be resolved. But in case beyond that, if you have doubt, we'll see what we can do about it. Well, I'll try to address maybe in some different way.
Sir, +1, sir. I have seen doubt in matrix and stuff.
Yeah,
Sir,
sure. So
even me, sir.
see, as I said, week 9 to 11, I am going to revise. So whatever important topics are there in week 2 9, I will revise those. That's already in that's my plan. So that will happen. Beyond that, after me revising, I mean, whatever my plan is beyond that, if you still have doubt with some point, we can go back to that concept and maybe I can try something different. All right.
Sir,
yes.
after the interim on 7th August, will there be any gap period for certain time?
Yes, there will be. Next term will start
September.
It's September, but it usually we release content on Friday. So either it will be 2nd of September or the previous Friday, which is 26th of August. I don't think it will be 26th of August. So most likely next term will start from 2nd of September, most likely. I'm not sure what's the decided time. It will be Friday, either 2nd of September or 26th of August.
Sir, will you
in either case, you will get definitely 15 days in between. That's for sure. At least 15 days you should get. Yeah.
You take the Python classes also in the next sem?
Yeah, if you pass CT, you can opt for Python.
No, like you will be the instructor there?
Yeah, I'm not sure. I mean, the next term allocation for instructor we haven't decided on, but almost or maybe even more than half of the content of Python is from my side. So,
Yes, sir. You said that only in the last.
Yeah, so it doesn't matter whether I'm instructor over there to conduct live sessions or not. Most likely I will be, but even though I'm not there, the lectures and tutorials are already recorded maybe. So I don't know what else I can say in the live sessions, but yeah. So that's the thing. Anything related to CT, Rohit, Varat, Siddharth?
Yes, sir. I have two questions.
Yeah,
difficulty.
Difficulty is something similar to what you have experienced before. Practice assignment, graded assignment, quizzes, it's same thing. End time exam it won't be anything different in that regard. It's just another exam, but instead of 45 minutes, this time you will get 1.5 hours, and the syllabus is entire course content. Beyond that, at difficulty level, there won't be any difference.
Sir, is it enough if we go through all assignments, graded assignments, practice?
That should be enough.
Yes, thank you, sir.
Sir, after week 12, there has been some content.
Yeah, there is some additional content. Do not even touch that content before 7th. Okay.
Okay, so is it a prerequisite for Python?
No, not a prerequisite. It's additional content which will help you in upcoming courses, not Python to be precise. It will help you in some diploma courses, understanding how computers work and some generic.
Which courses? I mean,
Okay.
what are the name of those courses?
Additional content. It
No,
will be
no,
there.
sir.
It's there on the portal.
Sir, I am asking about in which courses it will help.
Not any precise, any specific course. It is a generic thing for those who do not even know how computers work. Or I mean, see, something related to the operating system, something related to the object-oriented programming, or something related to the bottom-up or top-down approach. So these are some general constructs of computer science to be precise, not dependent on any specific course. So this is something which people learn in depth if they are doing BTech in computer science. I mean, we have not taught that at that level. Professor tried to explain that at top level using those, again, in the terms of cards and some simplified examples. But that's something is worth watching. But as I said, it's not relevant for interim exam. So do not even touch before 7th August. After that, as I said, you will get at least 15-20 days of gap. During that period, please go through those videos and whatever questions are there. And at that point of time, if you have doubt, please use forum, because we will not be having live sessions that time. But you can post queries if you have on forum. But as I said, after 7th, not before that. Don't even look at the content. It's not required for now. Yeah, 9 to 11 is sufficient for now.
Sir, you also
Just
said
last 2 minutes, then we'll start with the revision. Yeah.
yes.
Mock test.
Mock test, most likely it will be tomorrow. You should get you will get a announcement regarding that.
Sir, you are saying
We
1.5
wanted to do mock
hours.
test only after the revision, so most likely it will be tomorrow. Yeah.
You said there is a time limit for 1.5 hours. So what
Yeah.
will the question pattern? Will they double? For example, because of 50 marks.
I will not say double, because see, difficulty level is also important factor, right? It's not just about number. So
Because if you are doubling the time, then
Yeah.
obviously if number of questions
correct,
remain
but
same,
if you look at the
difficulty
graph
increases.
questions, right? Graph questions are takes more time as compared to maybe a general pseudocode question, or maybe a list question, which you might have taken, let's say, 10 minutes to solve a list based question in quiz 2. The same question this time, if you try to solve it, you might take 7 minutes or 6 minutes, right? Definitely you will take less time to solve a question which you have already done earlier. So
Yes.
Don't compute it mathematically like that. Okay, time is double, so number of questions double. It doesn't work that way. I mean, while framing a question, we have taken care that it should be solvable within given time.
Okay. And
I mean, this is not the first term, right? We have, this is, I think yours is 5th term, I believe. So there were 4 in-term exams before. So we have some understanding of how many questions students can solve in 1.5 hours. So based on this experience or even experience in general with respect to teaching, we have framed that paper. So don't worry about number of questions and all that. It will be solvable within 1.5 hours.
Sir, where we got interim paper, previous interim papers?
See, that's something I mean, there is no repository from IIT Madras where you can find it. That much I can tell you. That's something you have to find on your own. We don't provide previous interim papers.
Does anyone have?
Yeah, that's something you check outside, not during live session. That's not the way.
So, sir,
Okay.
we'll start.
Yeah. Anybody else have any doubt?
Yes,
Excuse me,
sir.
I'll start with the session.
Excuse me, sir.
Hello.
Hello, sir.
Yeah, Anushri.
So after this term, will we still be able to access the CT lectures?
Yes, you can. Yes, you can.
So anytime during the course, we can come back and watch
Yes,
the lecture?
you can. Yes, you can.
Yeah, okay, sir. Thank you.
Not just lecture, the whatever portal you are seeing right now, the entire thing will be accessible.
Oh, okay. Okay, sir. Thank you.
Yeah, thanks. Okay, last, Varat,
Sir.
do you have anything?
Yes, sir. Sir, I have opted for all the 4 courses, but on quiz 1 and quiz 2, I was able to see 4 hours of timing on calendar. But now on NTERM, I am able to see it's 9 to 12 and 2 to 5. So
Correct.
it's just 3 hours.
No, 9 to 12 is 3 hours, and again 2 to 5, right?
Yes.
That's 3 plus 3, 6 hours.
Okay, sir. So there will be 2 durations.
Yeah, you have to be there for those 3 plus 3 hours. Two subjects you have to give in the morning and 2 courses in the afternoon. That's how it will be.
Okay, sir.
Please
Sir,
wait.
which subjects in the
Please-
morning and which in the afternoon?
See, that's something. Please wait till you get the hall ticket.
Do you have any idea?
It will be.
Okay, sure.
All these details will be available on hall ticket, and you will get hall ticket by on 5th of August.
Okay, sir.
Okay, but just
Sir,
remember
may I
this
ask-
timing. You have to be there 3 hours in the morning and 3 hours in the afternoon. Just that's for sure.
Sir, may I ask?
Yeah, Pratish, go ahead.
Sir, I have taken 4 subjects this term, and maths helped me a lot to understand the later weeks of CT. So my question is that for the next term, like we have Python. So is there any dependency on maths? Because I am
No, there
taking-
isn't. There isn't. There isn't.
So okay.
Okay, and see, for next term courses, we will have orientation sessions, and that's the place where we will discuss again what courses to take, what combinations to do. That's something we'll discuss after 7th and after your results. We will have in those 15 days break, right? We will have orientation session for upcoming courses, and that time we will meet again, and that's the point where when we should discuss what to do next. Okay.
Okay, sir.
So let's not delay it. Let's start the revision part of the session.
Excuse me, sir, one small doubt.
Yeah, Karthik.
Sir, in CT, this thing, they added some 3 new tabs for additional content.
Yeah.
So they have. Is that there for this final exam, or is it something?
No, it's not. As the name suggests, additional content.
So it is also mentioned it is out of syllabus.
Exactly. Then what's the doubt?
No, it was put in this CT only, right? Because if it is,
it is a CT content. It is a
Yeah.
CT content, but it's an additional content, and it's out of syllabus. So this is something you should watch after 7th of August, after your exam.
Okay, sir. Okay, sir.
Okay. Okay, so let me start with the revision part of the session. So I have prepared, there are some slides which I will be using. These are same slides from week 12. So don't ask me to share slides. These slides are already shared with you. They are available on the portal under week 12. So I'll be talking about graphs, adjacency matrix, then some dictionary representation of the same, and the pseudocode which actually generates the matrix in general. So that's first. And then I will move to second PDF, the second version, where I will talk about recursion and DFS. Okay. So let me start. Let's assume that this is a graph. Yes.
Just can I ask one thing? Can these morning timings be shifted by 1 month, or where to
No,
talk
exam time will not change. It's fixed with the exam center. No change will happen with respect.
because in centers are very far.
Yeah, Rohit, I understand it's out of my control. If you have any request regarding that, please write to support team. But let me tell you in advance, no change will happen with that regard.
Thank you.
Okay. Yeah. Really sorry to be so blunt about few things, but that's how it is, and nobody can do anything.
No, sir, actually, microservices and Delhi connect the centers, so that's
Yeah, I understand. I understand
starts
all
bit
this.
at 8 because it's Sunday, so it starts at 8. So it will be helpful.
Sure.
That's why
Yeah. Okay. So as I was talking about, I will talk about this particular graph. So this is a graph in a pictorial form, right? We have 5 nodes. We have some n number of edges here, and every edge has a direction and a label. So whatever you have studied so far with respect to graph, all those things are covered. Edge, I mean, it's a directed graph, it's an edge label graph. And I mean, so far you have just studied these two types of graphs, right? So both these things are covered in this graph. Okay, so this is a pictorial form or as a picture or an image of a graph, right? The same graph can be represented as a matrix. How? As you know, rows and columns of that matrix is all the vertices of the graph. And if there is a age from 0 to 1, so you should read like this. This particular left, the first column, right? The first column, I mean, this is a row number and this is a column number. So you should read row followed by column. So when I say age from 0 to 1, that means from 0, 1, this 3. Why 3 is here? Because there is age from 0 to 1. If you check 1 and 3, so 1, 3, if you, sorry, 0, 3 we are looking. So if you check 3, 0, right? So 3, 0 is 7. That is different. No, sorry, I made a mistake. Okay. 0 to 1, 0 to 1 is 3. Why? Because we have age from 0 to 1 and the age label is 3. But if you look other way around, that is from 1 to 0, it says 0. Why? Because there isn't any age from 1 to 0. So this is not a symmetric matrix. It's a directed graph. So matrix is not symmetric. Okay. So this is a second way of representing a graph, which is called adjacency matrix. Why adjacency matrix? So every number in this matrix tells you whether there is a age or not. And if there is a age, what is the value stored against that age? That's what this matrix will tell you. And if there is a 0, that means there is no age, right? Then let's look at the third way of representing a graph, which is using a, I mean, this same matrix can be represented as a dictionary. And this is exactly what we are doing in our city course. Okay, when we say matrix, we are not storing this tabular format, because this table is nothing but, again, it's a two-dimensional structure, right? It's almost like a image only, but instead of this graphical thing, we have a tabular format. But still it's a pictorial form. Computer doesn't understand either the first one or the second one. What computer understands is this, a nested dictionary. Now the point is how this nested dictionary generated using this graph or this particular matrix. And this is the place, I mean, all the pseudocodes actually use this. So first you should understand how this works, then only you will understand how pseudocodes are using this particular structure. So when we say matrix, this is how the matrix is. See, so this particular matrix it's a nested dictionary, right? So at top level, there are 5 keys, 0, 1, 2, 3, and 4. So these top level keys are nothing but these row values. That's how you should treat it. These are row numbers. So these row numbers become our top level keys. And these column numbers becomes our second level keys. So for this row number 0, there are 5 different values. For this row number 1, there are 5 different values. Same thing we have tried to replicate using dictionary. For row number 0, there is column number 0, column number 1, column number 2, column number 3, column number 4. Against those, what we have? 0, 3, 0, 0, 8. 0, 3, 0, 0, 8. Right? That is how we are storing this particular graph or this particular tabular format of matrix into a dictionary of dictionaries. And this is something computer understands. Okay. And that's why every time when we say matrix, we are accessing a dictionary. And now the next part of it. Why we say always matrix of, I mean, usually you will say IJ or RC or something like that. But what is this? When we say matrix of 0, 4, we know it is 8. Why 0, 4 is 8? Because there is a age from 0 to 4 and label is 8. Sorry. Yeah. in this case, if you say 0 to 4, value is 8, right? Same thing, if you can access it using using this dictionary of dictionaries, right? So what we are saying, matrix is a dictionary. In that, you're supposed to access a key which is 0. Now, what is the key? 0 key. In that dictionary, at top level, we have 0 key. Now, this 0 key will gives you this entire dictionary. Within that dictionary, now you are supposed to access key number 4, which is this. And now, the combination of this 0 and 4 gives you 8. And that is how we found out that matrix 0, 4 value is 8. Similarly, matrix 3, 0, top level key number 3 and inner key number 0. Top level 3, inner 0. That gives you a value which is 7. And that's what it is. And if you see here, 3 to 0 is 7. So this is list of ages, right? So this is another way of representing the same graph. Again, I mean, this is a extracted version of this same dictionary. Okay, this is what computer understand. And this table only represents the ages, right? The zeros we have ignored here. That's how the general graph can be represented in all these ways. Okay. Now the next part. Every time.
Sir, may I ask a question?
Yeah, sure.
Sir, is it possible to label an edge as 0?
That doesn't make any sense, right? What label represents? The label represents either a distance between those two or a time taken to travel or some value, right? It has some meaning, don't you think?
Yes, sir. Yeah.
So it doesn't make any sense to have age label as 0. In rare case, I mean, you can cook up some application where age label is 0. In such a case, you will have to change your entire approach and make maybe -1 as default value or something like that.
Oh,
then you might say, what happens in minus? Maybe the age label can be even a negative number. Then what happens? Then you have to find some way that some value you have to find out which is definitely your age label, and that you can use as a your default value where there is no age, right? Maybe I mean that 0, 0, this age will definitely won't be there. So for this, maybe you can put infinity symbol.
Oh, okay.
Right.
Sir.
I mean that's something you do in mathematics, right? You put infinity, but computers again on a keyboard you can't type infinity, right? I mean, yeah, there is a way, but that's very tricky. At least in programming you can't. So that's why we assume this is 0.
For maneuvering through the columns and rows of the matrix, we have kept 0 and 1. But the values, it is not a must that it has to be a numeric value, right?
Yes, correct. See.
So in that cases, we can always, I mean, pull up some character where these things happen.
Yes. See, these column numbers or these row numbers will always be 0 to n-1. But these values can be anything. I mean, these actual values stored in the matrix, right? It can be an integer, it can be a character, it can be a string, or it can be a list. You must have seen some pseudocodes where we are storing lists inside one cell, right?
Yes, sir. Yeah.
So that's
See, for example, if I take an example of an apartment, where example in a single floor, you have 4 apartments, for example.
Correct. Yeah.
So to move from one apartment to the next apartment, how many floors you have to climb? It is 0 floors.
Right.
So in that case, if I want to make it as a 0, I can always say it is n, for example, as a character.
Okay. Yeah, I mean, so that's what, right? This is just a way you communicate with your computer, and accordingly you will write some logic, some code, right? Pseudocode or some language code which process this information. So accordingly you have to adjust your code also. Correct. This is what whatever I'm explaining you is with regard to what the kind of code which you have studied in CT.
We can store dictionary also.
Yeah, absolutely.
Okay.
See, what is this? What is this? This is a dictionary of dictionaries, right? So what you are saying is, instead of 3, I want dictionary. Of course, that is possible. It will be a 3-level nested dictionary. Are you understanding?
Yes, I'm getting
You
it.
can simply, instead of 3, you can have a list, you can have a dictionary.
Yes, we have a study that the value could be anything. So
Anything,
this the
exactly.
same applies there also.
Same applies here also because it's a nested dictionary.
Okay, understood.
Okay.
Sir, sometime you represent 0, 1, 0, 1, where there is a connection 1, where there is no connection 0, where it is used that kind of matrix.
Okay. So that matrix will come if there are no labels on the edges. Let's just assume that this is a graph, but every edge has some value, right? Let's say that value is not there. Only edges are there.
Okay.
Then there is a edge from 0 to 1, but that edge doesn't have value. Then what you will do? Okay, then you will put 1.
Okay. Understood.
And zeros will remain as it.
Okay. Understood.
Yeah. Okay.
Sir,
Yes?
how we can call the matrix of row 0, column 1 value if we are storing data in list form?
Okay. If you are storing value in list form, right? Let's say 0 to 1, there is a edge, and this edge represents, let's say, number of trains going from station 0 to 1. There is a possibility there are many trains going from 0 to 1. Let's say 0 is Chennai and 1 is, let's say, Delhi. And there are many trains going from Chennai to Delhi, right? So instead of these 3, you will have a list of all train numbers. So this matrix of 0, 1 will give you a list. Let's say capital L is equal to matrix of 0, 1. Now that capital L will store the list of all trains going from Chennai to Delhi. Right, Advain?
Yes, sir.
So that list you can iterate upon right now for each train in capital L. You can iterate on that entire list, right?
Sir, we can.
Are you understanding what I'm saying?
Sir, we can write down for each matrix 0 and 1. So it will iterate through the list, no?
Yeah, what you're saying is correct. So Aditya, hold on. Let me explain the person who asked. So Advain, are you understanding? So what we will write, let me write it here.
Yes, sir. That it will be more clear.
Okay. So can you see this particular dialog box?
Yes, sir. Yeah.
Okay. So I will write something like L is equal to matrix of 0, 1. Now what I said, 0, 1 is a list, right? As we discussed, it's a list of trains. Let's say, as I said, 0 is, let's say, Chennai, and 1 is Delhi, and the trains which are going from 0 to 1, right? Let's say train number 100, 200, 500. These 3 trains.
Okay.
These 3 trains are going from 0 to 1. So now matrix of 0, 1, L is equal to matrix of 0, 1. So what will be the value of L now?
The whole square bracket value is 100, 200, and 500.
100, 200, 500. So you already have a variable which stores this particular list. So if you want to access something specifically for each train in L, now this train variable, initial value of this train variable will be 100, then it will be 200, then it will be 500. You can do whatever you want with this variable. Or if you want to access specific one, then you can take first of L, you can take last of L, or whatever. I mean, it's just a list, right? You know how to process a list.
Yeah. Yes.
Got it?
Got it. Thank you.
Yeah. Again, instead of a list, it can be a dictionary. If it's a dictionary, instead of this for each trains of L, let's say if this is in some case, it is dictionary, right? Then in that case, you can only, instead of this, you will do keys of
keys.
Only that change will do. Now this train will be a key. So you can do something like this. This will give you that value.
Okay. And sir, one more thing, sir. Yes, sir.
Yeah.
Can you create one more variable called as matrix and store some value as a list? Means I just want to show that how we are entering the value in that variable.
Okay, so instead of let's say we are going from 0 to 1, right? So just say assume that this is not there, and instead of this we are storing that list here.
Then how we got to know that this is the value which is going from 0 to 1?
Because it is at
Because
0, 1 location,
okay,
right?
okay, got it. So,
Got it?
Yes, sir.
Okay. Okay, so shall we move? Okay, so next part is you must have looked at this particular function n matrix. And we always tell you that, okay, whenever we say m is equal to, usually we write something like this, right? Can I type without, okay, I have to highlight. Okay, then I can type. Okay, we always do something like m is equal to, then okay, the create matrix. Why it's not typing? You must have seen this particular statement in every pseudocode from week 8 onwards, right? This line will be there in every pseudocode.
Yes, sir.
And what we tell you, this creates a matrix of size n by n, and that matrix gets stored in M. What that will be, M is a matrix of size n by n, it will have all zeros in it. So what I want to tell you is how actually it works, and that's something you have to understand. You might think, why so far without understanding that I solved pseudocode, but it's worth understanding how it works, so that it will, help you better in understanding in general how that matrix is stored, right? So following up with what we discussed, so matrix is nothing but a list dictionary of dictionaries. Remember that part. So let's start. So this is our procedure. Sorry. Yeah, so we created a empty matrix. This is the number of rows, number of columns. In our case, yeah.
Just one small change. You wrote create matrix m cross n. So it represents elements 0 to n minus 1.
Right.
Or it is 1 to n.
0 to n minus 1.
Okay.
See, in computer systems, everything starts from 0. Humans, we start counting from 1, computers start counting from 0. So not just in CT, anywhere, whenever a computer is involved, counting starts from 0. Remember that. Okay.
Because in sessions, sir said that it is starting from 0 to 1 in model, but if we start from 1 to n, it does not matter. So I became confused.
No. It starts from 0 to n minus 1. Okay.
Okay.
Yeah. So that's why, as I said, I is 0, and while I is less than rows, as in whatever value this rows variable has, if that's less, we created just a dictionary. Okay, so this is matrix was a dictionary. In that we added this key I. I mean, let me demonstrate that with step by step. Okay, so let's assume that we are creating a matrix of size 5 by 5. Okay. There is a graph. I mean, if you looked at the previous graph itself, right? The previous graph was had a 5 vertices. So let's consider maybe that one. So 5 by 5. So because of that, initially line 1, we created this empty dictionary, right? Then we executed. Second is just a integer variable. Then we check this condition. Now values of rows and columns both are 5, 5. So I is 0, which is less than 5. We went inside. Matrix of I is equal to, again, empty dictionary. What is matrix of I? Inside this matrix, we created a key, which is I. What is value of I? 0. And against that, what is the value? It's a empty dictionary. So this particular matrix, now if you observe, it will change to this. When I is 0 and j, we haven't even reached to that point. The 0 will be added and this empty dictionary will be added. Now JL starts. This is the inner loop, right? This inner loop variable j. J is now 0. And now we are iterating on that. And for every ij, we are adding 0. And because of that, now if you see, when j becomes 0, we are adding one more entry inside that, because this is not matrix of I. This is matrix of ij, the second level. When second level is 0, we are adding 0. So that's why at second level, at that inner matrix level, this entry got added. Now you can tell me what happens when j becomes 1. We add one more entry into this inner dictionary. This highlighted the inner dictionary. And it will look something like this. I mean, after that j, you will add for 1, 2, 3, and 4. For 0, for every value of j, these entries will be added in every iteration. And that is where the inner loop terminates. You repeat the same process when I becomes 1. When I becomes 2, I becomes 3, I becomes 4, and that's where you stop. So this is how this create matrix works. In general, in most of the pseudocode, it is just one line code, but actually this much of code is running in the background. And the result is a dictionary. I mean, a result is a matrix. That's what we assume, but actually it is a nested dictionary in this form. So as I said, right, whenever we say matrix is equal to create matrix 5, 5, we always say matrix is this variable holds a matrix, but actually it holds this entire information.
So I have a question here.
Yeah.
Here, when we talk about matrix, then it would be a square matrix or rectangular matrix, both.
It will be a okay. It depends on what parameters you give to this particular matrix. If both is n comma n, then it will be a square matrix. If if the value for rows and columns is different, it will be a rectangular matrix. But in computational thinking, whatever we have studied so far, or in the course to be, I mean, now the end of the course. So in CT, we have never used rectangular matrices, right? Yes. We never had to. It's not that there is a restriction on that. There is no compulsion on using square matrix. We can, of course, use rectangular matrices, but we never had to.
Okay.
Because in graphs, we use matrix for what? To represent a graph, right?
Yes.
And in graph, every node we are supposed to consider on a row side as well as column side. So naturally, it becomes a square matrix, right?
Square matrix, yes.
That's the reason. Otherwise, there is no such restriction to use only square matrices. You can use rectangular matrix, but in terms of graphs, it has no meaning.
Okay, for graph related things, we have to use only a square matrix.
Naturally, it will be a square matrix, right? It's not you have to. Even though you try this, you cannot generate a rectangular matrix.
Yes, number of rows should be number of columns. Yes.
Correct. So naturally, it becomes a square matrix.
Okay, thank you.
Okay.
Sir, when this matrix will return an empty dictionary, I mean, when we pass 0, 0 as a parameter, will it return
when it is a 0, 0 parameter? Yeah, it will. I mean, as per this pseudocode, that's what will happen, because this code will not execute, and ultimately you will end up having empty dictionary. Yes.
Okay.
Sir,
yeah.
Can you please again explain that per matrix I equal to empty dictionary, like that word, how to execute first?
How to execute?
Means how to write that word, like matrix I equal to empty dictionary. What does that like mean?
Okay, this part, right?
Yes.
Okay, see what is happening. If I go back, this is where we are, right? This is where we are. The matrix is empty dictionary.
Yes.
So what I want to do, I want to add one row inside this matrix.
Okay.
Right? So in order to create that row, I will the first row. What is the number of first row? It's 0, right? The counting starts from 0, as I said. So
yes.
I've created that 0 row. So it's a matrix, right? So it's a dictionary ultimately. So how you add entry into dictionary? You create a key. And against that key, you store some value. So when I say matrix of I, it creates a key inside this particular matrix. What is the value of that key? I. And in the I is right now 0. So it created a key inside this matrix, which is 0. And against that key, we have assigned a value, which is another empty dictionary. So after this particular line, let me finish. After this particular line, the value of this matrix variable will look something like this. Yeah, go ahead.
I equal to 0, and in this while I less than 0, so row starts with 0 and it's also 0. So how it is?
No, the value of variable rows value is 5.
Okay.
See 5 comma 5, right? That's what we are calling. So value for rows variable becomes 5 and value for this columns variable also becomes 5.
Okay.
So we are checking whether I is less than 5 or not.
Yeah.
Similarly, j is less than columns, as in less than 5 or not. Okay. This example is for this particular procedure call 5 comma.
Sir, when I is equal to 1,
yeah,
how the values will be changed, sir?
Okay, so for I is equal
I
to
equal to 0 is fine, sir. 0
I is
and j
equal to 0.
Yeah, j becomes 0, 1, 2, 3, 4.
Correct. So in next case, what happens? Your I becomes 1.
Yes, sir.
That means you are supposed to add one more
key. Yeah.
Row, one more outer key.
Outer key, right?
Which is 1. And for
Yes,
that
sir.
one, again, j will start from 0 to till columns -1, right?
Yes, sir.
So for that, it will look something like this.
I have a doubt.
And again, it will be up to 4.
Up to 4, yes.
And after that, sir, that's my doubt.
So after that, after this,
Yes,
your
sir.
procedure terminates and it returns the matrix.
Okay. So this is going to be our final output for this code.
Yes. See, every time, as I was saying, right, in every pseudocode, you have seen this line. Either capital M is equal to create matrix. Maybe matrix variable was not there, but capital
Yes, sir.
M.
I have got the doubt that when
Yeah.
it is our previous graph, the
Yeah.
values are different. No, that's where I got confused.
No,
sir. Up to this part, I got
Yeah,
it.
this is what happens when you call create matrix function.
Only 5 row 5
Yes,
column.
it creates some empty. I mean, it creates a matrix of size 5 by 5, but all values inside are 0.
Zeros.
That's what we said, right? Every time.
Understood, sir.
This executes. This is what you get out of it.
Yes, sir.
After that, then we write our pseudocode in order to manipulate this, and then maybe there is some, if they have written a book together, if they are similar customer, if they can mentor each other with respect to scores data set and all those sorts of things we do, and accordingly we'll change values inside. Okay. But we start the entire process with this. That's my point.
This is the initial step.
This is the first step of any pseudocode involved in graphs week. Yes, sir.
Sir, can we say
Thank you,
every
sir.
matrix is a nested dictionary?
Yes, absolutely. Every matrix in CT, okay. I mean, there are many ways to implement it. In CT, this is how we are doing it. It's a nested dictionary.
Okay, sir.
Okay.
Sir, in many coded, we have initialized the value as a list, like every value in the matrix as a list or something like a dictionary.
Yes.
So we have to do extra from this procedure, like we have to do one more time. We have to define that.
No, then you just have to iterate over this matrix, right? For each I in rows of matrix, for each j in I mean, it's okay. So in that case, after this, right, after this whole thing is done, maybe I will just highlight here and add code. So what you will do is, so you have something like this, right? M is equal to create matrix, let's say in this, instead of that, let's say n comma n. After that, what you will write, for each I in rows of M, for each j in and this is the place where you will write M of ij is equal to. Now, if you want a list, instead of this, you want to replace all these zeros, right? All these values of matrix into list. You do this. And that now this M is updated. Now your every cell, I mean, a matrix has cells, right? This, if a matrix is 5 by 5 by 5, there are 25 cells in it, right? It's a 2-dimensional, it's a table. So every cell of that matrix or every value in that dictionary is now a list. Or you, instead of this, you can write even this, as per your requirement. But this additional code you have to write after this one statement. Whatever I'm explaining is with regard to just one statement.
Okay.
Yeah. Okay. Yes,
Sir.
Saurabh, you have raised your hand. Do you have any doubt or by mistake?
So the table which you have created, I mean, the table created there, have 2 columns and 25 rows.
Yes, correct.
But there should be 5 rows and 5 columns. That would make 25 cells.
Correct. What you are saying is correct. This table is not matrix. This table is the value changes for variables I and j. See, when value of I is 0, j changes from 0 to 4. When value of I is 1, j changes from 0 to 4. This table represents just how a nested iteration works. It has nothing to do with graph.
Understood.
Yeah. Okay.
Sir.
Yeah.
For if we want to change all the values that to a empty list or a dictionary, can we do that directly in the code of the procedure?
Then see, this procedure you never write, right? We just write just this one line and we get away with it. See, usually this line gives you a matrix. You never actually go in depth and check what actually this procedure is doing. So in that case, you will have to rewrite this whole procedure.
Oh, okay.
Which we never do, right? We simply assume that there exists something called as create matrix and it gives the matrix.
It becomes a different code. So,
yeah, then it becomes a different code. Then you have to write that procedure by yourself. Maybe create matrix of list. Maybe you have to create that your own procedure. So why to go to that trouble, right? Just call this once and write this loop. That will be easier job, right? Rather than writing the whole procedure.
Yeah.
Sir, we are just updating the value here, no?
Yes.
In for each.
Yes, only value. So when you do something like this, right? Let's say instead of a list, let me put space to make it a list. Okay. So if there is a list, right? Then what? Then every value, this 0 becomes empty list. 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 All these zeros, which are actual values, right? I'm not talking about these zeros. These are column names.
Yeah.
Column names will remain as it is. Row name
only value will get changed.
Yes, so all values will get changed to empty list. Okay.
Sir, here matrix I that is written in the first step. It will always remain dictionary.
Yes.
And rest of the things we can change according to the needs of the question. For example, value.
See, no, not just that. This structure will always remain as dictionary of dictionaries.
Yes,
inside
but
that
value.
Right now you have integers as values. These values you can, instead of integers, you can store floats, you can store strings, you can store another list, or you can store on the dictionary. That constraint is not there, but this structure will remain as it is. Because as I was explaining in the previous slide, right? A graph is represented using a dictionary of dictionaries. This structure you cannot change. The values inside you can change. For this graph, these are the values. Maybe there is a different graph. Values will change, but the structure remains as it is, which is dictionary of dictionaries.
Okay, sir. Okay. Understood.
All right. Anything else, or shall we move to next part?
Sir, I have a question.
Yeah. Yes, Shreya.
So, sir, so the pseudocode matrix ij gives the entry in the ith row and the jth column.
Correct.
So while solving the practice assignment, I'd come across some syntax of pseudocode, which was matrix I, j, and another term in another bracket. So it was I, j, and h, for example.
Correct.
So I couldn't understand that pseudocode.
So in that case, it was this. This code was executed, and now because of that, what happens is this particular value right now is just integer, right?
Yes.
Instead of this integer, now we have a dictionary as value. As in, there is a, I mean, if you have to represent that in terms of a graph, this particular thing, right? Right now there is a age from 0 to 1 and value is 3. So instead of this 3, now I have a dictionary as a label on that age.
Oh, all
and
right.
that is when you got that third H thing.
Okay.
Because it's a dictionary, and that dictionary again will have multiple keys, right? And
Yes.
those keys we will access using that third variable H.
Okay. Thank you.
I will be the source vertex, J will be the destination vertex, and H will be the key for each. I mean, it will be a key in a dictionary which is written on that age.
Okay.
Okay.
Yeah.
Yeah.
So can you show a rough thing for that? I'm not able to picturize it.
Okay.
Sir, can you
Yeah, sir,
please
can you
explain
write it?
how the pseudocode works of matrix?
That's what I just did, right?
Hello, sir.
Pseudocode. With pseudocode.
Matrix.
Okay. Yeah.
Sir.
Yes, Manpreet.
Sir, what is the meaning of return matrix in pseudocode?
Sir, please explain pseudocode, whole pseudocode.
This pseudocode, right?
Yes, sir.
I just did that. I just explained the whole pseudocode. You joined late or what? This is a simple pseudocode which you have studied in week 3. This is not new. Or maybe if there's a dictionary, then maybe the first week of dictionary, 5, 6, 7, week 7. This is from week 7. It has nothing to do with graph, to be honest. So yeah, so Manpreet, you are talking about what?
So what is the meaning of return matrix?
Yeah. So
This text.
return matrix is just the return statement. You are returning this matrix back. So whenever this procedure get called, what will be stored in this particular variable? Whatever gets returned from here. This is same thing what you have studied in week 4, I think, week 3 or week 4, when you studied procedures. Procedures always return something. And this procedure returns a matrix, which is nothing but this particular dictionary. So when we say this, it returns this entire dictionary.
Means it gives a result.
Yes. A procedure is supposed to give some result back, right? Otherwise, what's the point in returning or writing a procedure?
Okay, sir.
Manpreet, have you attended any live session earlier?
No, sir.
No, right? That's why, because this doubt is from week 3.
Okay. Thank you.
Okay. Yeah, sure. Thanks.
Hello, sir. Can you hear me?
Yeah, Chinmay.
Sir, my issue is with I got this matrix, it's okay, but when there are 3 rows comes, right, for each I in rows math, then comes for each K in column math, and then comes for each J in column math, and there I get confused. So how to go through this?
Okay, so over there is no, I mean, that's not 3-level nesting actually. We are still iterating on same matrix. Okay, let me maybe take example with, I mean, let's take this example. Okay, this particular graph we have, and this is the example what we have, right? So my point is, what happens in that case is, here you said you have I, J, and K, right? Let's say, okay.
Yeah.
So here I is going for all rows, 0, 1, 2, 3, 4. So that will be I, right? Your J will go for all columns, which is this 0, 1, 2, 3, 4, right? And then K will also go from 0 to 4.
Okay.
And what
So
does K
yeah,
will
so, okay.
I'll tell you. So simply take this example. Okay. You want to travel these 0, 1, 2, 3, 4. I mean, in this graph, all these are stations. Okay. And you want to travel from 0 to 2. Okay. Is there a direct path from 0 to 2? No, right? So your I is 0 and your J is 2. Okay. Chinmay, are you there?
Yeah.
Yes, your I is 0 and J is 2. There is no path from I to J. So you have to find some K which will help you to go from 0 to 2, as in from I to J. And what that K will be, K can be either 1, 3 or 4, right?
Yeah.
So what you do, you keep your I as 0, you keep your J as 2, and you start changing that K from 0 to 4. Now 0 doesn't make any sense because 0 itself cannot help you to go from 0 to 2. So you skip that. You move to next, which is 1. Now you check whether there is a path from I to K, then K to J, which is there in this case.
Okay,
right?
so every time this thing changes, like K changes to columns, then it changes to rows. Because when I'm doing
No, you don't see. You don't have to worry too much about that columns and rows. Columns or rows function always returns list of numbers from 0 to n minus 1. So it doesn't matter whether it is written as columns or rows. The value for that particular variable, for each whatever variable, that I, J, K, G, H or whatever, it will always go from 0 to n minus 1. No matter whether it's rows of M or columns of M or whatever. Okay, it will always go from 0 to n minus 1.
I don't have to think much, right? So when it's
You
I
don't
to
have
K,
to, don't worry about whether it's rows of M or columns of M. Whatever loop variable which you are using, right? I, J, H, K or whatever else, it can be even something else, right? It's just a variable. It will always go from 0 to n minus 1, no matter what. Okay. Yeah.
Sir, always rows are represented in the outer loop, right? And columns in the inner loop in this nested dictionary.
Yeah, right.
Matrix can't work the other way around, like
You
the
can.
outer loop.
No, you can. I mean that, but if you inverse that part, your code should also reflect that. The inner whatever logic you are writing inside that loop should also be modified accordingly.
Okay, sir.
It's a matrix, right? To be honest, in mathematics, it's a matrix.
Yeah.
It's up to you how you want to iterate it, row wise or column wise. No, but there is
So
no
accordingly,
restriction.
the code will change, right? Yeah, okay.
Accordingly, code will change. See, it's a naturally most of the people do it row wise, right? You first do entire row, then you move to next row. That's how
That's a
I believe
standard practice.
it's a standard practice, yes, because in India most of the schools teach it that way, so everybody is trained to do that way. But there is no limitation on that. There's no restriction that you have to do that way. Only thing,
Okay,
if
sir.
you change it here, you should change the code accordingly. That's the only thing which has to be there.
Okay, sir. Thank you.
Yeah, sure. Thanks.
Sir, one question.
Yes, Aparajit.
Yes, so where can we find the link to this Zoom link for this live session? This is the first time I'm attending. I got the link through WhatsApp, but where they are getting the link from?
Oh my God. On the portal, there is something called as about course. In that, there is something called as calendar. You're supposed to add that calendar to your personal Gmeet, your Google Calendar, and that's how you will know there are live sessions. And this is the second last live session of this term, and you're asking this doubt. I'm really sad.
I've been watching them on YouTube actually.
Yeah, but see, from where you are getting YouTube link?
No,
So Aparajit, maybe let's not deviate. I mean, I'll explain you where to get that at some other point of time. Okay. Let's not.
Sir, I have some question which is in with only specific to CT scope.
Yeah.
Okay. So in 0, 1, I have the number as 3. The edge weight of the edge is 3.
Okay.
Let me suppose the weight of the edge is a list which contains 100, 200, and 300, which you have explained in the last step, which are the trains, for example.
Correct.
So will I be able to access this as 0 matrix of 0, 1, and the second element, which is 2? Will I be able to access that way?
I think no.
Sorry,
I think no.
Can you repeat what you said? Okay, I got the point that instead of 3, you have this list as 100, 200,
Yes.
500. After
now,
that,
can I directly access this element 200 as matrix square bracket 0, square bracket 1, square bracket 1?
No. See, it's a
Okay, in
list.
scope, in CT scope, we cannot do that, right?
In CT scope, you cannot do that. Right.
Sir, in list we cannot directly access any.
Correct.
We have to go sequence. We have to go by
Yes,
sequence.
correct. So Karthikeyan, as you rightly pointed out, I mean, politically correct statement in CT scope, that's not allowed.
Yeah, that's right. Because it's array. Basically, it's array. But CT is not able to handle this.
Yeah, you move to Python, it is possible. Okay, but in CT
No, that's
scope,
what. See, I just want to, see, in case if some question is coming in the exam, asking to identify the error, I should not, deviate from this scope, right? That's
you should not. You should.
Yeah, okay.
So.
Okay, sir.
Sir,
Yes.
sir,
The CT scope too. It will do the first of first thing.
Yeah, you have to do that first of first will give you that 2. I mean, not first. You will have to do that init, the combination of init and in first. Not init at first, init and last, or the rest and first. That will give you that 200. Yes, correct, Saurabh.
Sir, sir, recently the example you have given that 0 to 2 we have not a direct path. So sir, we can go like 0 to 4, then 4 to 3, then 3 to 0 again, and then 0 to 1, then 1 to 2. Can we do that? I mean that the cycle from 0 to 0.
Hypothetically, you can,
yes,
but whenever you are trying to find such a path, right, you always maintain how much distance you have traveled, or some kind of value
minimum
you will
for
maintain for that, right? And you will always update that with minimum one, because you want to travel the minimum distance, or you should take minimum time. There will be some, based on application, you will apply something, right? Otherwise, in worst case, what will happen? You will keep moving 043, 043, 043.
Yes, sir. Yes, sir.
Right. So there has to be some way to do it properly, and that's where your DFS comes into picture.
Yes, sir.
Okay, when you execute DFS on this graph, all cycles goes away, right?
No, sir, but you have just given the example of I, J, and K. For that, you are iterating before K. So K for this procedure, it will also consider a path from 0 to 4.
It will definitely. Then the point is, inside those. Somebody asked about 3 nested for each loops, right?
Yes.
So inside those 3 nested for each loops, you should write a proper logic to avoid this.
Yes.
Correct?
That I got, sir.
Yeah.
Thank you, sir.
Thanks. All right, then shall we move to next presentation? Next points.
Yes, sir. Please.
Yes, sir. Please.
Yes, sir.
Okay, sure. So next is this particular. That's the last thing what I had over here. So moving to next one, this is the place where I will talk about first recursion and DFS later on. DFS, I will not go into details of code, because DFS code is not that crucial for CT. Only thing you have to just understand, okay, this is how DFS algorithm works in general. DFS pseudocode is doesn't have that much of importance in CT. Right, that's why you may not have seen any pseudocode related to DFS. The only pseudocode which professor explained in the lecture. Beyond that, you will not see. Even in questions, you will not see any different version of DFS. DFS is a standard algorithm which none of us can change. Right, so there is nothing much to do. So I will not go into pseudocode.
Questions only DFS is given. Yes. Procedure. DFS or something.
Only DFS. Depth first search. Yes. Avnish, you have raised your hand. Is it by mistake or do you have doubt?
Sir, I have to ask one graded question.
No, not now. If time permits, we can take it at later point of time, or else you can post it on forum. Okay. This is the revision session, so I won't be taking those questions. Okay, so let's first start with recursion. I believe most of you will have some of the other doubts with recursion, how it works and all that stuff. So we'll take simple example of factorial, which you all know what is factorial and how it is computed. So the confusion will not be on the example side, and let's try to address whatever doubts you have related to the process of recursion in general. Okay, so first, just some key points to remember about recursion. Recursion is a process in which a procedure calls itself, right? This is a standard definition of recursion, if we can say. Then all problems cannot be solved using recursion. There are some limitation in recursion that means every problem. I mean, recursion is nothing but which you write in order to avoid loops, right? You instead of loop, you can call a procedure recursively, but that doesn't mean that every problem is solvable using recursion. That's not the case. Only those problems which have a base condition can be solved using recursion. What is base condition? That we'll talk in next couple of minutes. Then recursion simplifies the pseudocode. Okay, in this just a general point. Now let's see. I mean, this is enough of theory. Let's see what recursions, right? With some example of this factorial. So pseudocode to find factorial of a number. This is without recursion. So if you see this pseudocode, I will just quickly go through it. So this is a procedure which accepts a number n and it returns a factorial of that particular n. So if n is 5, the factorial of 5 will be returned over here, right? And how to calculate a factorial? This is how the factorial is computed. We create an integer variable, initial value is 1. If while I mean, you know, while loop, so while n is greater than 0, fact is equal to fact into n, and you keep reducing it, right? So if we are calculating factorial of 5, it is 5 into 4 into 3 into 2 into 1, right? That's what will happen every time n reduces by 1, and we are multiplying with previous value of fact. So that's how it will be 5 into 4 into 3 into 2 into 1, because n should be greater than 0, and that's where this stops and we return the value. So this is standard procedure for factorial without recursion. Now let's convert this procedure into a recursive procedure. Now what happened? As I said earlier, right? All problems cannot be solved using recursion. I mean, when I said that, I mentioned that if there is a base condition, you can remove that loop and you can make it a simple code with recursion. That's exactly what we are doing here. Now we had this while loop. We will remove this while loop and replace with two different blocks. One is base condition and one is a general condition, whatever you call it. There is no specific name to it. A base condition, and there is some mathematical term to it. Sorry, I'm not able to recall, but yeah, you will divide this loop into two blocks, as in the if-else blocks, and get rid of that loop, right? So when n is equal to 0, you simply return 1. That's your base condition. Why? Because factorial of 0 is 1, right? If you remember from the school days, factorial of 0 is 1. So that's why if n is equal to 0, you return 1. That's a base condition. And in every other condition, what is factorial of 5? 5 into factorial of 4, right? That's how we treat it, right? What is factorial of 4?
4 into factorial
4 into factorial of 3. So this is naturally a recursive one, right? In order to find factorial of a number, you should know what is a factorial of that number minus 1, correct? And that's exactly what we have written over here. What is factorial of n? It is n into factorial of n minus 1. And if you have such a application, I mean, if you are writing a code, for example, where such thing exists, where this naturally, in order to find answer of this, you should know the answer of that. In order to find answer of that, you should know answer of something previous to that, or maybe something next to that. Then only you can use recursion with base condition. Yes.
Sir, the code written in left-hand side is a normal code.
Yes.
Right.
Yes.
And the code written in right-hand side is the recursion.
Correct.
And the both return value will be the same.
Yes, both will give you same answer.
Then why we are writing the recursion code?
Okay, so as I said, right, it is a different way of writing a code. Why every time you have to write a loop? Without a loop, if you can write a code, it is easier to interpret, don't you think?
Sir, I think recursion will do it much faster than this.
No, I don't want to go into that detail. That's something you will study in PDSA, and I don't want to disappoint you. but recursion is actually not faster. Recursion is actually slower than the code. But yeah, I don't want to demotivate you from using recursion. But it's a very important construct of any programming language. And as a programmer, we must know how recursion works and we should study it. And that's
what are the advantages, sir, for recursion? What are the advantages of doing about making a procedure into a for writing a code in recursion?
Okay, first is there are some examples, as I said, right, which are naturally intuitive, where this the way to find answer lies in either something previous or something next, right? In such a case, this is how we as a human we work, right? If at a school level, right, if I ask you what is factorial of n, what you will say? N into factor of n minus 1, right?
Yes.
This is how this can be written only in using recursion. You cannot have, this is what you have studied in school. See, if you are not talking, please keep yourself on mute. Who's that? Yeah. Okay, now it's better. Okay, so Siddharth, as I was talking, right, this is how we have studied to calculate recursion in school, right?
Yes.
So that's possible only if you use recursion. Without that, see, this is some way you are doing same thing, but this is not exactly, these two statements is not exact representation of this.
Okay, okay.
See, this is just a small.
So there is no computational advantage of doing recursion.
No. But when we try to analyze the code, it simplifies. It is easier on our minds.
Okay.
But computationally, there is no advantage, or in fact, there is a disadvantage, to be honest. And as I said, I don't want to demotivate you. And this is something you will study in depth in upcoming courses. But actually, there is a disadvantage computationally. But at human level, it is easier on our mind to interpret a code with recursion if it has that kind of a base condition.
Okay. No advantage as far as speed of computation or memory economy, nothing like that.
No. As I said, right, no advantage. In fact, there are disadvantages.
Okay.
Sir.
Yeah, Anushri.
Sir, if the value of n is negative or something like that, then this procedure won't work, right?
You tell me what is the factorial of negative number mathematically?
There is no 1.
It doesn't exist.
No, not defined, sir.
It's not defined, right?
Yes,
Yeah,
not
so
defined.
for this code, if the value of n is somehow negative, then it won't work, right?
Then the thing is, it doesn't have any base condition for this.
It will go infinitely.
See, no.
Sir, we have to give any if block.
Yes, correct. I mean,
we can use an if block.
Yeah, we can use one if block which says that. But what you will return? You can't return undefined, right? See, as I was telling you,
you can't return anything.
I'm not trying to write a code which is mathematically accurate or something. My point is to teach you recursion. Okay, so focus on recursion and forget about factorial. Okay? Yeah. Yeah, I mean, what other person said, just add one more if, which says if n is less than 0, return. I mean, now there is a confusion what to return, but yeah, you can return something. Which signifies as undefined.
Infinity.
Yeah, but you cannot write infinity symbol in code, right? Yeah. But anyways, I don't want to
better
go
wherever you are calling this
recursion.
procedure factorial, put a if condition and call the factorial. If n is greater than 0, greater than or equal to 0.
Yeah, do it other way around. But again, Karthikeyan, in that case, the problem is what the procedure will return. It will return nothing, right?
No, you can handle that. No, when you are calling this procedure in the else block, you return like this is an invalid call.
Correct. I mean, you have to put some print statement or something, right? I mean, that's something we don't do in CT, but correct. Anyways, let's not deviate. The focus is recursion, not factorial.
Sir, can you show how this return value will work, sir? Else part in recursion?
Yes. That's what these remaining slides. I mean, can you see the 24 slides? So remaining next slide onward, that's what we'll do. Is it clear, this translation from plain code to recursive code? If that's clear, let's move to next part.
Yes.
Okay, great. Okay, so the next part is let's that the same code, whatever was there on the left hand side, sorry, right hand side, this code I have taken here. But now in order to execute this code, we have to assume some value for n, right? So let's assume n is equal to 5. Okay. So with n is equal to 5, we will execute this code step by step. I mean, every step, I will not skip any step in between. So because of that, now let's replace n with 5, right? Every place 1, 2, 3, and 4. There are 4 places where there is n. Let's replace that n with 5. Now what happens? You are calling this procedure with 5. Now 5 is equal to 0. That's not true. You went to else part. In else part, what it says, return what? Return 5 multiplied by factorial of 5 minus 1. Now you cannot return immediately. Why? Because you do not have this value with you. You just know I am supposed to multiply whatever this value is with 5 and return that value. But in order to do that multiplication, you should first know what is factorial of 5 minus 1, as in factorial of 4. That means you are calling this procedure again, but now this time instead of 5, you are passing new value, which is 5 minus 1, 4. So that generates another procedure call. And guys, if you have a doubt, please be patient for some time and don't disturb in between, because it breaks the flow. I will take all your doubts as soon as I finish explanation from my side. Okay. So please be patient for a few minutes. Let's not break the flow. Okay. So as I said, because of this factorial of 5 minus 4, we got a new procedure call, this one, this red color one. And now the parameter or the value which is passed is 4. Again, 4 is not equal to 0. You execute else block. In else, again, what we do, what is factorial of 4? It is 4 into factorial of 4 minus 1. Because of this, again, it generates another procedure call. And let me tell you, this previous procedure call is not yet completed. It is put on hold to compute this value. Again, this procedure is execution put on hold to get this value. And this generates next procedure call, which is now with 3. Same thing, this procedure, red color procedure call will be put on hold in order to execute this particular call, which is with 3 minus 2, which is in now 2. Same thing will continue for 2 minus 1. That generates this procedure call. Now this will generate the next and last procedure call in this case, because now ignore this 0 minus 1. Okay, computationally it will be like that, but as you know, the input value is 0. 0 is equal to 0. We return 1. So it will actually never come here. So no need to be worried about that part. So 0 is equal to 0. We return 1. Now the important question or the important point for all of you to understand is where this 1 goes. When we say return 1, this 1 should go somewhere, right? It should be returned back to some location. Where it gets returned? The place where this procedure was called. Where we called factorial of 0, it was called here, right? Factorial of 1 minus 1. This particular highlighted part initiated this execution. So this return 1 or this 1 value should go in place of this particular procedure call. And that is the next step. Can you see this particular red thing computed return 1, and this 1 goes in this place, which is this one. From here, now we can return. Earlier we put this procedure call on hold, right? The execution we kept on hold because we did not know what is the factorial of it was not known to us that what is the factorial of 1 minus 1. Now we know factorial of 1 minus 1 as in factorial of 0 is 1. We can do this computation 1 multiplied by 1. Now it is possible. That means now we can do 1 into 1 as 1 and we can return 1. Now where this 1 will get returned? the place where this procedure execution started, which is over here, right? And because of that, now it will be something like this, 2 into 1. Now this 2 into 1 again goes where? The place where this particular procedure started, which is over here. So now 2 into 1 is 2. This should replace 2. Sorry, 2 should replace that. So 2 came here. Again 3 into 2, that's 6. This 6 will go over here because that's the factorial of 3, right? 4 minus 1. 3's factorial is 6. It went there. Now 4 into 6 will go to previous procedure call. So all these procedures we kept in earlier on hold, right? Now they have started completing this execution in a reverse order, right? In a reverse order, they are completing its execution. Now 4 into 6, that's 24. It goes there. And now we can return the final answer for the factorial of 5, which is 120 in this case. Now I'll stop here. Now, before moving to DFS, if you have any doubts on the recursion, I'll take those doubts now.
Sir, can you just slide back to the previous slide?
Yes.
Just slide.
Yeah. You ask your doubt. I'll take that slide. I mean, it's a same slide with some manipulation on it. So what exactly your doubt is?
Sir, in programming means we can hold some procedure. Means we can hold some procedure.
Yes, we can. Yes, we can. I mean, whenever you write a recursive code, that's what computer internally it do. What it does, it puts a procedure execution on hold and starts a new procedure execution. Then a next execution, then a next execution. That's what computer do internally every time you write a pseudocode with a recursion. There are many ways to do it, but recursion is the one which you have studied so far, where a computer puts a procedure execution on hold purposefully in order to get some next result.
And how computer understand that this is a recursion code?
That's very easy, right? The procedure name, whatever is there, that same name appears inside the code, right?
Yeah. Until it not gets return value, it means it's a recursion.
Yes. See, in this return statement inside bracket, either you should have some value or you should have another procedure call. If it's a procedure call, it will be a recursive call.
Recursion call.
If not, the value will be there, which you have studied till week 10, right? There will be either true or false or some variable you are returning.
Correct.
Yeah. Yes, Aditya, you have raised your hand.
Sir, I am asking that whenever we go to the base value, then we backtrack from there itself, right? Till the starting point.
Correct.
So it will take, it will take twice time, and it is holding also something. Then it will store some memory also, no? So.
Okay. So what's the point?
I mean, it's take more in a general. If we compute in general by while loop, then it is looking like similar computation in both in while loop also and in the recursion also.
Yeah. Okay. So I never said recursion is more effective. In fact, that's what I was saying earlier. In fact, recursion takes most of the times recursion takes more time than a loop. I totally agree with that. That's not the point. See, it's important construct to study. Computationally, whether it's an advantage or a disadvantage, that's something. The analysis of algorithms you will study in detail. How to compare algorithms and how to check which one is faster, which one is slower, and all that. That comparison you will study. I mean, you will get fed up of these comparisons. The entire 12 weeks of PDSA course, right? Programming data structures and algorithms. You will do these comparisons. Which algorithm is faster? Which algorithm is faster, and how we can make some slower algorithm and convert into faster algorithm, and all sorts of those things you will do. Right now, that's not the point. Right now, the point is to understand how recursion works. Whether it is in faster or slower, don't worry about that right now.
No, my backtrack was a little bit confused, but now I'm clear.
Yeah, that's important. If you have understood how recursion works, we have achieved the motive of this concept in this course.
Okay, sir.
Sir, I have a doubt. So for example, if in some other part of the code, we are calling the procedure factorial of 4.
Okay.
So will recursion occur there, or will we take the value from this recursion of factorial 5 and directly put it in that?
See, where you are calling that factorial of 4?
After calling the factorial of 5 in the main code.
In the main code, right?
Yeah.
So what happens? The same procedure will happen, but it will start from this point onwards. This first part will not execute. So this whole thing will happen, but it will start from this point towards right and bottom.
Yeah, my question is, for in factorial 4, the else part is return 4 into factorial of 4 minus 1, right?
Correct, yes.
But before this, if the code has factorial 5, in that it is already processed, right? The factorial for 4 and factorial for 3 is already processed. So
yeah, but
can we
never we never kept that information anywhere, right?
Oh, it's not stored, so it's
not
lost.
stored. It's not stored. We are simply returning back. It's like you must have played that game, right? Pass on that until the music is playing, you are passing the pillow or something like that, right? It is same thing like that. You get something as a return value from some different procedure call. You give it back to the previous procedure call.
Oh, so it's not stored anywhere.
It's not stored. It's simply returning. Do you see any variable where the
no.
value is being kept? No, right?
No.
Yeah. So that's why that's not possible. I mean, right now that's not possible. Okay.
Okay.
I mean, there is something called as memoization. I don't want to go that. I mean, it's possible, but right now let's.
Yeah. Okay. So yeah.
That concept is there in PDSA again.
Yeah. Okay.
I just remember, maybe if you are interested, maybe after exam you can search for that. I'll just give you that.
Okay, sir.
This PDSA actually is in the second year, or it's a part of the first year?
No, it's a diploma course.
Okay.
Sir, in a recursion process, is it possible that a procedure call a parameter, I mean, multiple times, the same parameter, like here, can this procedure call 5 as a parameter once again in this process?
No, not possible, right? I mean, you are always calling with what is the code for this? Call it again with n minus 1. If you call it
not
again
in
with
this
n,
case, not in this case. First, if is there, I mean, exist any example?
No, right? See, if you are calling same procedure again with same parameter, it will be a never-ending thing, right?
Yes.
What output you will get? You have to change that parameter in order to get to call the next. I mean, before the next procedure call, right? Otherwise, there is no meaning to that code, right?
Yes.
Yeah. See why we are calling it? Because answer of this lies inside this. Or other way around. I mean, in order to find answer of this, you should first find answer of this. That's how it goes, right?
Yes, sir.
Yeah, that's why we have to do it. If you call it with same, then you will never get the answer. Not just this example, any example for that matter.
Okay.
Yeah. Yeah, so somebody was asking, yeah, I've just posted it, that you can look at that.
Yes, sir, yeah.
So,
Yes, sir. Thank you.
Yeah, but as I said, for others, it's not from CT. Don't worry if you did not understand, because it's really a complicated topic. Yes, Parag, do you have any doubts, or shall we move to DFS?
No, sir. No, I just moved on.
Hello, sir.
Yes, Manpreet.
There are two sections in a recursion. Which one, sir? Which are those? Base and.
See, this is a recursion, right? So this is base condition, and this is the other part of it. That's what I said. I don't remember exactly what the name.
Oh, okay, sir.
Don't worry, nobody will ask you, but if you want, I will just find out and I'll tell you. I mean,
above one is base.
No. This one is base.
Just above. Okay.
See, yeah, the above one is base. It's not always that above one is base in all cases. See, the thing is, the place where return statement has some concrete value, it's the base condition. And a block where you're calling the procedure again and again, that's the recursive call part of it. So this block is the recursive call. This block is responsible for that recursive block. And this block is that base code where the actual some concrete value is being written. Yes, Dev?
Oh, okay, sir. Thank you.
Dev?
Okay,
Yes,
sir.
sir. I've been holding my doubt for sir when you explained the recursion. At the end, I was not able to understand that when you did 5 into 24, or you did, I think.
Yeah.
That's why I said to just show me the side. I can't after that. Yes, this value.
Okay.
This how did it come?
It came from here. You did 4 into 6, right?
Okay, 3 into 2, 1 to 1.
See, hold on. This is where we were.
Yes, sir.
So what is factorial? I mean, this at this point 0 is equal to 0, you return 1.
Okay, sir.
Where this one goes?
This one
goes the place where this was called. Factorial of 0 was executed.
Oh, okay.
Here.
Now get it. Okay.
Get it? So keep going back one
step.
Back.
Okay.
Back.
That's why it is a long process.
Yeah, it's a long. See, initially with this, we started the procedure calls, and from this point onwards, we started closing those procedures call in a reverse order.
Yes, I know. Okay.
Yeah.
Yes,
okay. Then
so I have just a general query, sir.
Yeah.
If this is a long process, then just for building the base, we are studying it or learning it.
No, it's not actually a long process. See, I mean, in order to explain it, it looks long like that way, but it's not actually a long process. If you see the actual number of times the execution happens, it's same.
I'm asking about actual code, the code you wrote at first for factorial, in which the number was multiplying by its predecessor each and every loop.
Correct.
So I thought that would be an easy one if we wrote it in code also. So recursion will take more time, or that code, or both will be same.
So as I said, computationally, which is faster, which is slower, don't go into that right now. That you will study later.
Yes,
on.
That's what
I already mentioned, right? That's something. There is a dedicated course for that. Okay. So let's not go into that right now. Your focus should be on understanding recursion. Okay.
Thank you.
Yeah. Let's go step by step. Don't try to directly climb to floor number 4. Okay. Yeah. Okay. So yeah, fine. Then we'll move to next part of it, which is DFS. Okay. So yeah. So we'll take this very small graph and we'll try to process it using DFS. Again, a step by step, we'll see how everything happens with respect to DFS. So I've used some colors as in each color comes into picture. I will tell you what that color represents. It's the same thing, which I believe was there in the solve with us session, the previous solve with us session or something. So anyways, don't worry if you have missed it. So the point is there are 5 nodes and there are 1, 2, 3, 4, 5 edges. And we are supposed to start DFS from vertex number 1. Of course, in order to execute DFS algorithm, we should know the starting point, as in the starting vertex. In this case, the starting vertex is 1. So this is the place where we will start. Okay. So that means our 1 is now is something called as known to us. It's explored one. I mean, not yet fully explored, but this is known to us that there is some vertex which is 1. And this dark green color things, they doesn't exist so far. So far we just know that there exists a vertex which is 1. Okay, that's why we added that 1. Now from 1, we have to start that depth first search. So from 1, now we have to see how many neighbors the 1 has.
Check after.
Yeah. So please keep yourself on mute. Who's that? Ashmina. Yeah. So for 1, we have 2 neighbors, right? Which is 2 and 4. There are 2, but we can only choose 1. And we have taken this liberty of saying whichever is smaller, we'll explore that one first. I mean, in the lecture itself, professor took that liberty and assumed that that's how we'll do it, just for simplicity's sake, right? So there is a choice between 2 and 4. So 2 being smaller, we'll choose 2. Yes.
If it is not given explicitly in the question that to choose smaller one or bigger one,
you choose smaller. You choose smaller. And in CT, that you just assume that it will not be required actually. But if that's the case, you simply choose smaller. Okay.
But if options don't coincide, then what to do?
No, that's what I'm saying. The correct answer will be assuming that you have choose smaller. Okay. So if there is a choice, you always choose smaller. Then only you will get the correct answer. Okay. So let's continue. So that's why we are supposed to select that node 2. And now, as I said, 1 has 2 and 4, right? These 2 options are there. And from these 2, we decided to select 2. So now 2 becomes that yellow color thing, right? And 1 is blocked. I mean, 1 is done. Now there is nothing, but we moved away from 1. Now we are at 2. At 2, again, there are 2 options, 3 and 5. The orange color one is the available options. So available options, again, we are supposed to select 3 because that's the smaller one. Now we are at 3, we closed on 2. We moved away from 2 to 3. At 3, if you see, there is no option because only connected node for 3 is 2 and it's already closed. So this is the point where we are stuck. As per DFS tree, we have reached a point where we cannot go further in depth, right? Depth first search. We have stuck on the lowest possible depth. So this is the point where we should go back. The technical term is backtracking. We should go back to the previous place from where we came to 3. How we came to 3? We came to 3 from 2. So you should go back to 2. Right? You went, I mean, that step is missed in between, but yeah, you go back to 2. At 2, now only possibility is 5, right? The 2 is closed, so only possibility is 5. So you explored that 5. Now 5 became yellow, and for 5, the only possibility is 4. So as there is only one possibility, we move to 4. Now for 4, if you see, there is nothing else. There is no possibility. There is no point in backtracking. You can go to 5, you can go to 2, you can go to 1, but there are no remaining vertices to explore. And that's where you stop. And that's your output tree. And this thing I have mentioned earlier also, but it's a very important point which many people miss, that input for a DFS tree, DFS algorithm. See, every algorithm takes something as an input and gives something as output, right? So this depth first search, a DFS, takes a graph as an input and tree as an output. It's not other way around. Please be sure of that part. Please be clear of this. For DFS algorithm, our input is a graph and output is a tree. I hope you all know what is the difference between graph and a tree.
Yes.
Okay, so with that, from my side,
what is the reason for that?
Okay, just hold on. So with that, I will stop here. Now, if you have any doubts with respect to DFS, let's start with that.
So what is the difference between breadth first search and DFS?
What is the difference between DFS and BFS, right?
Yeah.
Okay, so DFS, as in you keep going in depth. And whenever, as we said, right, you went from 1 to 2, 2 to 3, and you stuck here, then only you were looked back. That is DFS. And in BFS, from 1, you should do 2 and 4 both first, then only you should check for next, because 1 is connected to 2, 4. So you cannot move to 3 or 5 unless and until you complete 2 and 4, because you complete the entire breadth.
1 has connected with 2. So that is second level. So you finish that whole level, then you move to next level.
Okay. Okay.
Yeah. Anyway,
So
I mean, BFS algorithm in detail, we are not studying in CT, but that's the idea behind BFS.
No, it was a question in the practice assignment, so I just.
Okay. Now,
sir, is that a recursive algorithm?
Yes,
BFS?
it is a recursive algorithm. Yes.
No, sir. BFS.
Yeah, BFS also you can write it as a recursive algorithm. See, what is the process? Naturally, what you are doing, whatever you did for 1, you are doing same for 2. In terms of DFS, or even in case of BFS, whatever you did for 1, you're supposed to do that same for 2 as well as 4, right?
Yes.
So naturally that becomes a recursive algorithm. I mean, you can put in extra efforts and write a non-recursive algorithm, but naturally the process itself is recursive.
So I have a question. Like in the interim exam, we will be given whether we have to traverse sequentially or not randomly. So it will be given, no?
Given what?
Like we have to traverse like 1 to 2. There from 2 we have 2 options: go to through 3 or 5. So it will be given whether we have to go sequentially, like 1 to 2, then 3, then 5. Like a smaller number. If we have 2 edges, then we have to go to the smaller edge first. So,
yes, you have to. No, I don't know. I mean, whether it will be explicitly mentioned or not, but that's how you should do it, because that's how professor did it in the lecture. So you simply
actually
in
the maths lecture there is a random also, so that's why I'm asking.
Sir, actually
no. Forget about what is there in maths. In CT code, you will do like this. You will do the smaller one first.
Okay, sir.
Okay, yeah.
So edges in input graph and DFS tree need not need to be same, right?
Sorry?
Edges in input graph and output DFS tree need not need to be same, right?
It will be a subset of that, right? That's the difference between graph and tree. So whatever edges you have in a tree, all those edges will definitely be there in the graph. You cannot have an edge in a tree which doesn't exist in a graph. Then there's something is wrong. So all these edges, 1, 2, 3, 4, all 4 edges has to be. It's a mandatory. I mean, otherwise your DFS has done something wrong. So these edges will be there in the graph, but not other way around. Graph will have some additional edges.
Excuse me, sir.
Yeah. Yes.
Sir, in output DFS tree, we cannot see the edges between 1 and 4. And if question asks predict the input graph, then how can we go?
You cannot predict input graph using output tree. That's not possible.
Okay, sir.
You cannot predict it, but you can tell whether a specific edge may or may not be there. That small thing prediction, it's possible, but entire graph you cannot predict.
Okay, sir.
I mean, I can tell after looking at this tree, I can tell there is no way there is an edge from 3 to 4. 3 to 4 edge doesn't exist. If there is an edge from 3 to 4, 4 would have been added below 3.
Yes, it is definitely we can.
Yes, so that much we can tell, but beyond that we cannot construct whole graph using tree. That's not possible.
Okay, sir.
Yes. Okay, so Dave, do you have any doubt? You have raised your hand. So please, if you have a doubt, please raise your hand so that I will know you have doubt. Yes, Dave.
Sir, I had some doubts. So first of all, the difference between a graph and tree, I wanted to just clarify. Tree has acyclic. That much is the difference, or can you specify me the difference I'm missing out?
Yeah, it's acyclic, and you will not find any edge from lower vertex to. I mean, that's acyclic only, but yeah, that's or even at same level you will not have any edges. See, in a tree you will keep going from root node till leaf node. There is a I mean, you will traverse from top to bottom. There is no lateral movement or a backward movement from some vertex to go back to root. That's not how it works.
So that is the difference between a tree.
You keep going level by level, or you go back the same path you came down.
Okay. And
which is not there in a graph.
Okay, and also, sir, if we would have made a BFS tree, so that in this only, when we got to 4, from 4 point of view, 1 was not explored, but 1 was explored at the start only. So that's why we didn't get got to 1 only. But in BFS at we see that it is a queue. That is, we select 2 and 4, then we check 2 has, but we do 4 first. So in 4 also, if we find 5 and 1, we write it also and we do it again. So
but 1 will not come there. Again, over there, we have to check whether 1 is already visited or not. 1 is visited, so you're not supposed to use 1 again.
Okay.
That logic remains same. Otherwise, you will never end the process, right? You will keep doing it again and again and again. It will be a never-ending thing. Somewhere you have to take a decision. Okay, this vertex I will not explore again because it's already done. You have to take that stand at some point, right? Otherwise, it's a never-ending thing.
Okay, so means in BFS there will be had been 2 edges. That is one from 1, 2, and 4 will be there. From 2 will be carry on that.
Correct. So at the top you will have 1. Below that you will have 2 and 4, and below 2 you will have 3 and 5.
3 and 5, and from 4 we will have nothing, no? That's what I'm asking, because 3 and 5 are explored there.
Correct. But see, why you are interested in BFS in CT? Nobody is going to ask you even a single question on BFS in CT. Okay, so don't.
I had doubts from this part only, from math
don't
also
mind.
graph.
Dev, I don't mind answering your doubt. That's why I'm here. My only point is, do not waste your time studying BFS. Okay? Study only DFS.
So
for CT, maths course, I don't know what is happening there. For CT, only study DFS. Forget about BFS.
Okay, so I had also one question, but I will ask it last as you are continuing on this session. So if you let time, I will be there. Okay, sir, I will ask.
Yes, Karthikeyan, go ahead.
Sir, my doubt is outside of this DFS. If you are finished with this, please consider me for some other questions.
Okay, fine. I'll come back to you. Anushri?
Yeah.
Sir, is DFS a procedure or is it
it's another algorithm? Just like DFS, BFS is a separate algorithm. That procedure we haven't studied in CT, so we will not be asking any question on BFS procedure pseudocode. It's not there in syllabus.
Okay.
No, sir.
So BFS is just an algorithm?
Yes, BFS is another algorithm just like DFS.
Is it not BFS, just DFS? Yeah.
DFS is just an algorithm. I mean, it's an algorithm,
so
right? So there will be a procedure.
So we just have to know the what happens in it, right?
No, you should know the algorithm, right? I mean, it's some 4 to 5 lines of code, actually. If you go back and look at the slide where the DFS is explained by Professor Madhan, it's 4 to 5 lines of code, actually.
Yeah.
Right. So.
Okay, sir.
Yeah. Okay. Next is Rohit. Rohit Raghavan,
Sir,
are you there?
I want to know the functioning of explode.
Functioning of explode.
Yeah.
That
because
is something.
There is a question in practice assignment week 11 where it is asking for a palindrome.
Correct.
Identification of palindrome.
Rohit, explode is something which is related to the second week of this. I think week 6. Go to the lecture of week 6. You will find explode explained over there. It is used in week 11, but the concept is from week 6.
No, I'm not asking for explode. Explode.
Explode only. I'm talking about explode only. In whatever you are saying, right? The palindrome example, right? Using explode.
Yes.
It is explained in I will tell you, convert a word into a list of letters. Okay. Week 5, in not even week 6. Week 5, lecture number 6. The lecture name is List, Construction and Operations.
Okay,
lecture number 5.6. Watch that lecture, you will know what is explode. And the palindrome business. Okay. Yeah. Dev? Or you already asked the doubt, right? And you have something outside. Yeah, I'll come
Yes,
back.
sir.
Yeah, Kaushik.
Yes, sir. Sir, first question is, sir, if the vertices are changed like different cities of India, then how they enumerate this 0, 1, 2 and others number to that vertices?
Yeah, so that's say you have to assign a number to every city, because the way we have written our entire logic is based on sequence numbers, right? You have some unique sequence number in order to process that the matrix in the first place, which stores that the graph. So you will have to assign a unique number to each city, and you can process those numbers.
Okay, sir. Okay, and
which we have done many times, right? If you look at many questions where we said, okay, our books are named from 0 to m-1, or our customers are named from 0 to n-1. We have done that many times earlier.
Yes, sir,
So
but
that same thing we will do for cities also.
Suppose the cities are already given, and the graph is not connected graph; it is a disconnected graph.
Okay.
Then we'll still work on that.
See, DFS algorithm is executed only for connected graph.
Okay,
if it's a disconnected graph, then there is no depth, right? How will you execute a algorithm on something which doesn't exist? In order to execute a graph, there has to be an edge.
Yes, sir. Yes, sir.
Right.
For connection or another.
Yes, if connection is not there, then the concept of depth doesn't exist.
So then we have to take those two components as different input graphs, and then
yes, correct, and that will give you two different trees.
Different trees, yes, sir.
Yes.
Okay, thank you, sir.
Yeah. Okay. Sure. Thanks. Okay. Anybody else apart from Karthikeyan or Dev who has any doubt related to DFS?
Sir, I have a doubt. Can there be more than one correct tree? It's like more than multiple trees can be there for a single graph.
Yes, it's possible. But as I said, if you assume that when there is a choice, if you decided to select the smaller one, then you will get the unique tree.
Okay.
Right.
Okay.
I mean, if the choice is between 2 and 4, and I told you every time if there is a choice, you explore the smaller one first, then you will get the unique tree. But in principle, yeah, what you say is correct.
Okay, sir. Okay, thank you.
Yeah, thanks. Okay.
Sir?
Yes, Narayan.
Please describe DFS pseudocode, how it's work.
It is there in the lecture. There is a dedicated lecture where Professor Madhavan explained the DFS code. Why do I have to explain same thing again? I mean, I can't do better job than what he did. So, do you know there is a lecture where he has explained that pseudocode?
Yes.
Then why don't you go and watch that lecture? Okay, so we will
week 2.
Week?
Sir, it's in week 2, sir.
Week 2? No, he's talking about pseudocode of DFS. It is in week 11.
Oh, yeah.
Okay, so all right, so with that, let's finishes our revision, and within time, which is 10 o'clock. So I'll stop here, and if somebody has, I mean, Dev and Karthikeyan asked, they have some doubts. So let's take those doubts from some assignment questions, and then we'll close the revision part of the session.
One doubt, sir, can I ask?
Yeah, Vishwajit, what's this regarding?
Sir, in reading pattern, sir, there are two options. I mean, one is 60% weightage from final exam, and one is 50% weightage from final exam. So if I score like out of that, I mean, in term exam, if I score well, sir, so I mean they will, because quiz 1, quiz 2.
No, it is for those who have given only one quiz. Have you given both quizzes?
Yeah.
Then you will be eligible for the appropriate one accordingly.
So
then it will be 50, then it will be a 50%.
Okay.
No, it's not better, right? How will you predict that ends and go will go well for you?
No, somebody said it is best 1 out of 2 quiz.
No, it's not. Is it written best out of 2? No, I don't think it is only for those who miss
It
one.
is a 9. It is a 80% for one quiz and 90% for both.
Okay. Yeah. See, these operational details. Please refer to the grading policy and what is there. It is the final one. Okay. It's not a city question. So any city questions, I will take questions from Karthikeyan and Dev. But so if you have a city related question, please raise your hand and wait for your turn. So first, yes, Karthikeyan, go on.
Yes, sir. Sir, to discuss my question, I am taking the graded assignment 10, question number 6, but it is not specific to that question.
Okay, but okay, let me also see. Week 10.
Graded assignment 10, question number 6.
Question number 6. Okay.
But question, I mean, the discussion is not, I mean, pinpointing that question.
Got it. Continue. What's your doubt?
Okay. Now, if somebody is going to ask me to solve this question, given a pen and a paper and a quiz, I'm definitely going to take not less than 15 minutes, 12 to 15 minutes to solve this.
Okay.
So I want to know your approach for this type of questions given a pen and paper.
Okay.
Because you're definitely going to, I mean, consume less time. So I want to understand what is your logic in solving this question so that we can at least grasp something from your logic on how to approach these type of questions.
Sure. First of all, we don't even need pen and paper. Okay. Throw that away.
Okay.
I mean, if you keep some track, it's good, but actually it's not required. See, first understand question properly. You don't rush into pseudocode directly. First step. Read every step given in, I mean, in text form, whatever is given, that is equally important, like pseudocode. Okay. Don't miss that part. So we have, I mean, I know these questions. I will just quickly brief, summarize that part and then we'll move to pseudocode. Okay.
Okay.
So we have books, which is a dictionary. In that, keys are the numbers of the books labeled from 0 to m-1, and value against that key is a list of authors who have written that book. So for example, book number 0 is written by authors 0, 2, and 3. These 3 authors came together and wrote this book number 0. Okay.
I'm with you, sir.
Yeah. So that's the information given to us. So with that, let's start with 6. So in 6, I think we are already assuming that this particular thing we have to do. I mean, this matrix, whatever is computed in 5, we have to assume that exists, right? The following pseudocode creates adjacency matrix 2 of another graph H. Okay, so it has nothing to do with question number 5, right? So we are supposed to compute this matrix for some graph using books as that dictionary which I was talking about for 2 different authors, I and J. Remember, 2 different authors. So I and J will be different values. For point to note here. Okay.
Okay.
Then what does the value of matrix 2 of IJ represent at the end of execution? Right. That's what the question is. Now, I mean, if this question is given to me as fresh, I will tell you how I will try to go approach this. Right. Okay. So matrix 2 create matrix n comma n. So we got a matrix of size n by n. Then we are iterating on J in rows of matrix, K in columns of matrix. For every JK, it is a list. So that means this matrix was initially with all zeros. Now after this, we converted that matrix into all lists inside. So it's a matrix in which the lists can be stored because we want to store lists, right? Because every book is written by list of authors. So it's not just one number, it is list of some authors, right? That's why we changed all zeros to empty lists. So that's till line 6. Okay.
Right.
Right. Then next, for each I in keys of books, that means I is something which will go from 0 to m-1. Why? Because what is keys of books? Keys of big books are all keys of that dictionary. And what is all keys? Keys are all the book names. Right?
Serial numbers. Yeah.
Serial numbers of the book, which is from 0 to m-1. So I will go from 0 to m-1. J is what? J is books of I. What is books of I? Books of I is a list.
List, sir.
List of all the authors who have written book number I. Correct?
Yes.
So that list. So J will iterate on that list.
Okay.
Now that list will be of size 2 or 4 or 20 or 40. We don't know. But it will iterate for all authors of that book I.
Okay.
K is again doing same thing. Right?
Right, sir.
H is also doing same thing because see the code is same, right? Books of I, books of I, books of I. Only thing the variable changes from J to K, K to H, right?
Okay.
But in general, these three loops are doing same thing. They're iterating on list of authors which we have for book I.
Okay.
Right? So this part is done. Only part remaining is this. And this is the place where the actual logic, the entire game is being played, right?
Right, sir.
Now, the first part is we are checking J should not be equal to K, J should not be equal to H, and K should not be equal to H. That means this three variables should be unique. J, K, H. All three should be unique. Then only we will execute this. Otherwise, we'll completely skip it. Right? Next. Now, not member of this. That means this matrix of JK, it's a list, right? We already.
Yes.
So in
we already
list,
in this empty list. Yeah.
Correct. So in that list, if H is not there, then only we are executing this. Because we said not a member, right? If it is not a member, then only we are executing this.
Okay.
If it's already a member, don't bother. Do not execute these two lines.
Okay.
Right? So what this part is, inside JK, we are looking for H. Remember this. Inside for JK location, we are looking for H.
Okay.
Okay. That means two variables, and this is the third variable which we are looking at, a location pointed out by two variables.
Okay.
I mean, all three are different one, and we are not checking for JK and K again. That's not happening. A location created by two variables, it's a list, and in that list we are looking for third one, which is J, K, and H. I mean, these three, that's the combination we are looking for, right?
Okay.
Now next, what we are doing, if matrix 2 of JK, we are appending H. So for JK, we are appending H and storing for JK. Similarly, we are doing it for other way around. For KJ, we are appending that to KJ and storing in KJ.
Okay.
Right? So this is standard, I mean, pseudocode part of it. Now, the thought process behind these, I mean, this pseudocode. Now, what is happening? What we are doing, we are looking for some H. Okay. Because see, every place we are appending H. We are checking whether H exists in this list or not. So H is something which is very crucial in some sense. Why? We don't know, but it's crucial, right?
Right.
And what we are doing, we are checking whether that H exists for KJ or not. But if you remember from where that H is coming from, H is just an author who has written a book with K and I, K and J, right?
Right.
Because we know, see, these people have written book together, which is book number I. So J, K, H, all are co-authors naturally.
Okay.
Right? Because that's what we said, right? We are iterating on list of authors who have written book I. So J, K, H, all are co-authors. That information is already known to us. And then we are checking whether value H is already there for J and K or not in that list.
Okay.
Sir, I have one more question.
Hold on, Aditya. Don't disturb in between. So what is the point here? That means we are checking whether somehow H is there in this list or not. And if it is not, we are adding that into the list. That means H has written a book with J and K.
Okay.
And if that is the case, I mean, and as per this, they have written a book. So we are adding H into this list.
So what is happening, then you can, I mean, once you analyze this, we can simply take this example. Your J is 0, K is 2, and J is 2. What is the sequence of
K and H?
J, K, and H. Okay. So your J is 2, K is 2, 0, 2, and followed by 3. So for 0, 2, as in the matrix 0, 2, the location which is pointed in matrix by 0, 2, we are checking whether 3 exists in that list or not. If it exists, we are ignoring it. If it doesn't exist, we are adding 3 for location which is pointed out by 2 and 3. What does that mean? 2 and 3 have written a book together with 3.
2 and 0, yeah.
Sorry, yeah, 2 and 2, 0 and 2, they have written a book with 3.
Yes.
Similarly, 2 and 3, they have written a book with 0.
It is creating a symmetry in a sense.
Yeah, exactly. And that will happen for every different combination of values, unique values for J, K, and H. Initially, I said 0, 2, and 3. Maybe next time 0, 3, 2. Next time 2, 0, 3. 2, 3, 0. There are 6 possible unique combinations for these 3 values, right?
Right.
So for all those values, the original matrix will be updated.
Right.
So what does that signify? Each value in the matrix of IJ, what it signifies? I and J have written a book with list of authors at that location.
Okay.
Are you understanding?
I understood, sir. See, so if you are done with the thing, then I will move on to my part of it.
Yeah, go ahead.
Okay. Now, see, I ultimately understood this, but how I understood this, that played a critical role. See, what I did, I took a paper. I put 4 columns, I, J, K, and H. And I wrote down the value of I, J, K, and H, and then I ultimately derived this answer. But I want to know whether this approach is always going to work out given the values, or it's a time-consuming approach, or you have some other approach which is easier than this, because that was what I wanted to understand.
Okay. See, your approach is not wrong, but as you said, first it will be definitely time-consuming, and second, it may not be correct every time. Because the example of 4x4 matrix, whatever you took, right?
Yeah.
Those 4 examples may not cover all different possibilities across the whatever is information given to you.
Okay.
But that's something you have to be very careful of.
Yeah, that was the reason for my question. Like, how would you approach it? Because as you said, if it is without pen and paper, definitely I cannot even think of it without pen and paper, at least at this stage.
See, I understand that's the point. See, this is not a programming course, okay?
Okay.
This is a thinking course. It's a computational thinking, right? So why this course was introduced to you in the first place? To make sure your logic, your logic or your thinking capability should improve.
Okay.
Okay. So whatever you were, imagine a pseudocode from week 3. Remember when you were in week 3, I'm sure you were using pen and paper to solve that pseudocode.
Absolutely, sir.
But today you can solve that pseudocode without pen and paper. Just by looking at code, you will know what is happening.
Right, sir.
That happened because you spend some time on it, and you have reached a level where that is possible. Now for me, I can solve this pseudocode without pen and paper because I have reached that level. It takes time, but that logical thinking evolves.
Yeah.
It is not a skill which you can grasp or you can learn by reading a book. It is a process. It takes time. It requires hard work. It requires practice, but it evolves over a period of time.
Okay, sir.
For somebody, it takes more time. Somebody, it takes less time. That's up to individuals' way of doing things, but it happens over a period of time with practice.
Okay, sir.
So I understand this graph will take more time as compared to something from week 3 or week 4. It is more complicated, but it will happen over a period of time. Just, as I said, keep practicing.
Hopefully, sir.
I'll tell you, it will not happen. It definitely will not happen before end term. I'm sure of that. But that's something you have to keep doing it, right? That's why you will see similar things in our upcoming courses. But that time, instead of pseudocode, you will see Python code. Maybe a way of representation will change, but graphs will continue to be there.
Right, sir. Right. True. Thank you, sir. That answers my question. Thank you so much. Sir. Thank you.
Thanks.
One question, sir. One question. Sir, in this code, 13 line is not necessary to write, right?
13th line. This one, huh?
We will go to when we are iterating, we'll come back to kj means j will get the value of k and k will get the value of j while we are iterating through these loops.
Yes, that is true. But it's not incorrect. You will save on one step.
But you need not write this 13th number line, right?
You can. If you want, you can skip that. But only thing.
It was just my query. That's why I asked.
No, your query is right. Your query is right.
So even if we don't write 13, the code will execute correctly, right?
Yes, it will execute correctly because this part will return true for that particular instance.
Yes, sir.
Yeah. So yeah, that's correct. It will save some time, right? If you do it in a single iteration itself, you will save some iterations if you do so.
Can you just explain this not member? Because if you said that J, K, and H are iterating through it, and there, just as you took the example of book 0, 0, 2, and 3 are there, but not member matrix is there. So in as we consider H to be 3, it is not member. Can you explain this not member part?
Okay, what do you mean? First of all, this is from
because
week 5. Yeah. So member is a function.
No. Member, I understand, sir. Okay. No, I'm not asking that. I understand not member means if it is not this member, then it will come evaluate to be true. I know that.
Yeah.
But why we are using this on? Why we are using this? That's what I'm asking.
Okay. I'll tell you. What is happening is, say, I will go in for the explanation of this. I will go in the reverse order. What is the answer? List of authors who have co-authored a book with both I and J.
Yes, sir.
Right. So I and J, there is a list of authors, right?
Okay.
So for example, there is an author who have co-authored book with IJ multiple times.
Okay.
Then that person will come in that list those many number of times.
Yes, sir.
Which we don't want. We just want a list of authors who have co-authored a book. We don't want to check how many number of times somebody has co-authored a book.
Okay. So first time when
so in order to avoid the duplicate values in same list, we have written this part.
Okay. So first time when he was not there, then
yes. So first time if somebody has written a book with J and K, H will be added. If H is already added, there is no point adding that same person again, right?
Yeah. No.
That is why this part is there.
So can I ask my query now, sir?
Yes. Anyway, you are the next person in the queue. Yes, Dev.
Okay. So first of all, sir, I'm not having any problem related to such pseudocodes and all. Okay. The problem main I am having in both every quiz and this is error finding. Which we have to find errors. Sir, each and every time, even I tried a different approach just as to see the options. Just if in comparison to options, if the pseudocode is very long, so I just look at the options and I see if there is something wrong with them or not. But also sometimes it works, sometimes it's not. This error finding is I'm finding it quite difficult to tackle through it.
Right.
This I want to ask. How can I approach such questions?
Okay. I will tell you how I approach it. I mean, it may or may not work for you. I mean, everyone has their own way of solving same question, right? So I will tell you how I approach it. Maybe you try that. If it works for you, good, or else I don't know what to do. But I'll tell you what my approach is. Okay. Let me take some small example. I will not solve the question, but I don't think in week 10 there is such a question. Maybe I'll go to some previous week. Okay, anyways, I'll just tell you verbally. What I do, I first try to understand what the pseudocode is supposed to do.
Okay.
As I said, the text given, right? The English text given before pseudocode is equally important to pseudocode. So I will pay very good attention towards that text. I will try to understand that first. All right.
Okay, sir.
Then I will start reading the pseudocode as if I am writing that pseudocode myself.
Okay.
That means I am supposed to find, let's say, max total marks from scores dataset. Okay, very basic one.
I get it. Yes, sir.
Then I will try to, in my mind, if I am the person who's writing the pseudocode, how I will write it. That's how I will keep imagining when I read the pseudocode line by line.
Okay.
Then if I find any mismatch between my thought process and what my eyes are looking at, then that's the place where I will mark that line number.
Okay.
And then only once I finish the entire pseudocode, then only I will look at the options.
Okay, sir. Actually, what happens in this error finding question, it is multiple select.
Correct.
So the thing happens, such as initialization of some variable is there, or incrementing of variable is there.
Yeah.
So I think I will do the same thing, but I didn't get the point it should be above the line or it should be below. So these type of in the question it is below the line, such line which where it should not be. So I think no, it is okay. Then I will just do it. Okay, it can be dynamically initialized and all. But the actual outcome will be the correct one, that it should not be there. It should be up there. And the procedures also.
It is important, right? Sometimes some statement being inside loop or outside loop matters, don't you think?
Yes, sir, that matters. Actually, when I get it wrong, then I know that it matters.
Okay.
After
so again, it's a practice thing, right? So maybe pull out all the questions where error finding type questions are there and solve all such questions again. It's a matter of practice. And as I said, right, this is my approach. It may or may not work for you. So
no,
maybe try this one if it works.
Yes,
good.
sir, I will try. I'm trying my but I will try this.
Yeah, I mean you must have tried many approaches. Let's try this one.
Also, sir, one thing is there. Is there going to be another session with you or any other CT session is there?
Yeah, one more CT session is there day after tomorrow. You can check in the calendar. On
Thursday,
Thursday,
yes,
it's there.
So my main concern was I have been in problem with this train data set questions. I had some problems with them. There are some questions. So right now session is they passed the deadline.
See, why to wait for sessions? Post it on forum, no? Why to wait for another 2 days? I mean, it's day after tomorrow. You have to wait for 48 hours. Don't do that. Post it on forum. We'll try to address it there.
No, sir. Telling my problem verbally is quite more easy than telling it before on forum. Yes, sir. People answer, but I can't get the gist.
Yeah, I understand. Of course, it's more effective.
I'm very inactive on.
Yeah, so it's there on Thursday. Thursday 8 to 10 session is there, and that session Rahul will conduct that session.
Okay, and sir, just last question. Is there any mail about weightage? Because I didn't receive any mail also, and then opened also.
No. Formally from our side, there is no weightage.
Okay, just as in stats, maths, there is specified.
No. For CT, there isn't anything like that.
Okay.
See, for CT, everything is interlinked. Even when when you are solving graph question, list and dictionaries are there, pseudocode is there. So there is no clear weightage as such. That's why we never announced that.
From start till end, it is just building up the process.
Exactly.
Intermingled questions.
Correct. So that's why there is no clear weightage. So we have never announced it till date in last 2.5 years. Okay.
Okay, sir.
You are not alone for which this is happening.
Okay. No, sir. No, I thought something, but okay, sir. I will come to you or Rahul, sir, in that train of question.
Yeah, sure. As I said, right? So yeah. So you.
That's fine.
Yeah. Sure.
Sir, on what topic discussion would be conducted on Thursday?
It will be a general concluding session, so it will be more like open session. But that will be. I mean, the plan is to do that session after mock. So more focus will be given to mock questions, and if you have some other questions, we'll have those questions also. And see, why precisely mock? Because mock will cover all the questions from all weeks, right? I mean, roughly all weeks representation will be there in mock, which is the thing for interim exam. So usually that session will be based on mock questions, but you can always ask some other question also. So it's more like open session, but targeted towards preparation for end term exam.
Okay.
Yeah.
So mock will be for 1.5 duration, 1.5 hour duration, or
I guess so, or maybe 1 hour. That's something, I mean, I have to say. I mean, you haven't received any mail regarding that, no?
Okay, but it will be time mock.
Yeah, it will be time mock, but questions will be available later on for practice, just always.
Okay.
Yeah, I mean, we are planning to have it tomorrow night. I don't know. You guys should have received email today itself. Let me check that why there is a delay. Okay. Yeah. So yes, Chinmay.
Yeah, sir. The practice assignment 10, question number 4. So I just had an issue.
Okay. Yeah, tell me.
So if you just check it like this, you don't have to check the code also, right? This is an AND operator, right? I to J is true and J to so and
line number.
No, I am just checking. So when you check it, so if you see the options, right?
Yeah.
So you just come to know that since it is an AND operator,
Yeah.
true, false, true, true. So there's something like that. So do you have to actually check the questions when you get a question like that, like this?
Yeah, you have to check all the options.
Yes. So
when you get a question like this, you have to read all the options. Yes.
Yeah. So if I go through this, so if I see the AND operator, so I click the AND gate, right? True, false, true, true, and the last two options. False, true, it should be false, and false, it should be false, right?
Okay.
So if I check, the last option is not falling, the last fourth option. So from my side, I think 4 options should be correct, right? Going with the same logic.
So you are saying this one, fourth one?
No, last second one.
This one?
Yeah, false, true should be false, right?
False, true is false, yes. See, it is not, see, that's the point. You should not try to analyze the pseudocode based on just this condition. There is some background happening before that, right? That's also you have to understand that what that particular thing is. Just you by looking at AND operator, you cannot give the answer. If it's not that straightforward, we never ask. I mean, how do you expect us to ask a question that straightforward?
Okay.
Right. You have to understand the whole pseudocode, what is happening. That's why I said you do not direct. I mean, first of all, don't ever jump directly to pseudocode. First, understand this. Then start reading from line number 1 to 12. If you directly jump to line number 10, you will get incorrect answer. Yeah. So first try to understand the whole pseudocode, what is happening.
And there is one more question, sir. Grade assignment 9. You have explained this, but I was not in the live session, so I was not able to get it. Can you just come down? The last one, I believe.
Do you know the question number?
Let me just have a look. Yeah, this one.
Okay.
No, the comp science one, the computer science guy. The last one, I believe.
Okay.
Yeah. Just above this one, sir. Yeah, this one. So, no. So give me just a sec. Okay, I forgot the question number.
Okay. So Karthikeyan, you have raised your hand. So after this, we'll close the session. It's already.
Yes, sir. That is with respect to mock. I'm just waiting for the other gentleman to complete so that.
No, anyway, he's finding the question number.
Okay.
So
see, my thing is like before 2 or 3 sessions, I in fact raised this to you, like the mock examinations. Like it is clashing with my working time because I am not from India. I'm placed somewhere else.
Yeah.
So this timed mock is, I mean, really clashing with my work time because before I come from work, the time ends.
Yeah, I understand, Karthikeyan, but what's the solution? Tell me what solution we should.
No, I see the solution. See, I'm not proposing any solution, but at least if it can be, open for a day, like the other mocks, like English and all the stuff.
Yeah.
And then you can.
Will be open. See, you submit a mock or you do not submit a mock. That's not the point, right? It's about under that time pressure, you should be able to solve those questions.
Yeah, that's right. See, that
I'll tell you an alternative for you. Usually we upload all the question in a PDF format
along with the mock. For every graded assignment also, I don't know whether you have noticed this.
Yes, I noticed it. Yeah.
Yeah, so that PDF version of questions is there. So just download it and solve it offline and time yourself. I mean, that's the best solution I can give you. We cannot
I
have
understood.
mocks for 2 different time zones and all that.
I understood. See, last time I was proposing, like, see, whenever someone starts a mock,
yeah, I know.
your
I know
timer
that,
should start from
I
that
agree.
time.
I understand that, but unfortunately, the portal doesn't allow that functionality, at least at this point of time.
Okay, sir. Okay.
Yeah.
Fine.
So that because of that limitation, we cannot have that. Otherwise, there are many things we can, many different things we can actually do with that. But I don't know whether it's coming or not. But as of now, it's not there.
Okay, sir. Understood, sir. Okay. Thank you, sir.
Sir, I got the question number 14.
14.
A little change is required.
14. Yeah. Next one. This one. Yeah.
Yeah, this one. So if a case equal to 1, if c equal to j, return true. So this is the code I'm not able to comprehend. Because earlier what we have, this is some hop question, right? So if you go to I to j, j to I, something like that.
Yeah.
We are just hopping from one place to another. Here I am not able to comprehend how are you going to do this, because if c equal to j, I become confused. My mind goes blank there. So how should I approach this?
What is happening is, this is, I mean, have you understood what is happening here in the first place?
Yeah. I have understood it. Just explain
We
by
are
your
finding
own.
that ancestor part.
Yeah, sir.
We are finding whether that ancestor part.
Yeah.
So we were trying to find whether I is the ancestor of j or not, right? It returns true if I is the ancestor of j, right? So if I is the ancestor of j, we are supposed to return true. So what is happening? I mean, let me see what's the correct answer. So I will explain accordingly. What's the correct answer? The option number? It's 1, 2, I think second one, right? This is 1.
Third one, I believe.
Third one. This representation is so bad. Okay, fine. So whichever is true, that doesn't matter. Let's see what is happening. I will go to that answer part. So what is happening here? You are iterating on. I mean, you are starting with flag, right? And you are iterating upon every what you say, every value in the column. That means obviously it will go from 0 to n-1, right? And for that, we are checking something like this, right?
Yes.
Now, what is happening? You are checking whether A of KC is equal to 1. What is K and C?
Rows and columns, I believe.
No, what is K in the first place? C's column is coming from here.
Yeah.
What is K? K is the
row, I believe.
No. K is the I value. I as in what? The person who we are supposed to check. Who we are supposed to check, whether the ancestor or not, right?
Yeah.
So that's our K. So what is happening? We are checking whether that K and C is equal or not. That means K and C is the age or not. So we are checking whether K to C. C is again changing value, right? As per the loop. So for every C, we are checking whether this age exists or not.
Yeah.
If it exists, we are checking this C is not equal to J. Now what is J?
C is equal to J, right? We are checking.
No, we are checking whether C is equal to J. Now what is J?
J is the maybe son. Yeah, the second.
No, J is the person which we are supposed to check.
Yeah.
If I is the ancestor of J, so J is the next level of I, right?
Yeah.
So that's what if we, that means we are trying to find some C which is equal to this as well as equal to this. Then we are returning true simply, which is obvious, right?
Yeah.
Now the point, I mean, that part is the easier part. Now the important part is if this condition doesn't match, then what happens?
Exactly.
Right? If that condition, I mean, let me get that. Yeah. So if that condition doesn't matter, what we are saying, we are checking, we are k is equal to c. We are making k is equal to c and we are exiting the loop. No, flag is also true. That okay, this one I guess, the last one. Yeah, we are making k is equal to c. That means now we are updated the value of the person from whom we started our execution. Or what is the original value of k? It was I, right? That is, we started execution from I. Now we updated that value.
Now it's changing to C, right?
Yes, we are changing it to C. Whatever the previous C what we had, right? And I mean, flag is again set to true, and we are repeating that from C to next C.
Yeah, C to next C. Yeah.
Next,
So
next
now
C to next C. So a step by step you are going ahead. So if you can relate that with some graph, right? Do we have some graph for this? Yeah. So let's take this example. So what you are doing is you are moving step by step from 3 to 0, 0 to 1. Your C is moving one step at a time.
Okay.
And accordingly, you are checking whether the ancestor sequence is there or not.
Okay. So each and every time K is also changing, C is also changing, right? Once you
yes, correct. See, C is anyway, it's in the loop. So definitely it will iterate from 0 to n minus 1. And if it doesn't match, we are manually changing that K like this. This is not loop, but manually we are doing.
Manually we are changing. Okay, got it.
Got it?
Yeah.
Just maybe do one thing. I'll maybe, I mean, because of time we cannot do it. Do one thing. Try to fix this correct answer code into this missing block and try to execute this for some different variations of this particular diagram.
Okay.
I mean, you yourself take some values for I and j randomly and try to execute it. You will know. You will try to understand it better.
Okay, got it.
Okay.
Thank you.
Yeah, sure. Thanks. Okay, last question, Vishwajit. Then we are stopping. Vishwajit, yeah, go ahead.
Sir, actually, I have a minor doubt. I mean, not a big doubt. Sir, it's about week 11, activity question 5.
Activity question. Okay.
Yes, question number 2.
Activity 5. Okay.
Yes, sir, question number 2. Sir, I think according to the correct option, I mean, we're getting. Yes, we're getting the. I understand this pseudocode. According to the correct option, we're getting the answer within a bracket, isn't it?
How will get the answer within bracket?
If you just look at the return statement, yes, then it's.
Oh, okay. You are saying there is an extra. There is extra.
Yes, sir.
Okay.
Yes, sir, exactly.
So hold on. This one is for. Okay. Yeah, I understand. It's there should be one less bracket in all options.
Yes, sir, exactly.
Okay. Yeah, you're right. You're right.
Okay, sir, that's it.
Yeah, you're right. It's a typo. We should fix it. But yeah, what you say is right. But I mean, don't worry too much about these details.
Okay, all right.
Will the computer return an error for this, sir?
No. See, I'll tell you what happens. Computer will not give you error because round bracket is mathematical thing. I mean, even in programming languages, and forget about R pseudocode. You do this in any programming language, you will not get error. Because a round bracket, you either add or you don't add. It doesn't have much of an impact. Even in maths, we have studied that, right? Sometimes you can add a bracket or you do not add a bracket. You can still solve that statement, that particular expression, right? So actually, computer will never give error. But yeah, as it's a mistake, I'm not denying it. I'm not giving any excuse for that. We should correct that typo. But yeah, in general, as somebody asked, computer will not give error. That's for sure. Because it's a round bracket. If it's a square bracket or something, then it's a list. Then it's completely different way of looking at it. Then computer may give error depending on whatever is happening. because then it will consider as a list, then that's a problem. Here round brackets, computers process them just like mathematical expressions, it will be ignored. And because of that, you will study something in Python, and when you study that in Python, you will know why that comma is there. And in Python, you will study that there is some extra comma you have to add every time, which you will find annoying. But this is the reason you will add that comma. You will talk about that in week 5 or week 6 of Python. Okay, just remind me when you guys talk to me in Python. Okay, the same round bracket and comma thing. Yeah, tell me. Yes,
so you told that there would be a holiday gap between next quiz exam. So will there be any quiz exam next month, or there would be quiz exam directly on October?
See, your term starts in September, so there will be some exam either in September, later half. I'll say last week of September, or maybe the first or second week of October. That will be the exam date. I don't remember exact dates where your next quiz one is, but definitely in August you will not have any exam. That much I can assure you of.
Okay, sir. Okay.
See, the term starts at some point, and the quiz one is based on first 4 weeks of content. So you will not have quiz one before we cover first 4 weeks of content, right?
Yes, sir.
Yeah. You just do the calculation.
Thank you, sir.
Yeah, sure. Thanks. All right. So we'll close the session.
Thank you, sir.
Thank you. Thank you. There is one last session on Thursday. So if you still have a doubt, that's the last chance, or the forums are always open.
So will you be there for the last session?
No, as I said, Rahul will be taking that last session, but I might join for some time if possible.
Oh, okay, sir.
Mostly
okay,
the session will be conducted by him.
Okay, sir.
So we simply divided, right? Yesterday's session by Deepak, today's by me, and the Thursdays by Rahul. It was equal distribution. So
yes, sir.
Yeah. Okay, fine. Bye.
Thank you,
bye,
sir.
everyone.
Thanks a lot, sir. Thank you. Good night.
Thank you, sir.
Good night.
Thank you, sir. एक क्वेश्चन सर ग्रेडेड का था
हेलो
सर एक ग्रेडेड का क्वेश्चन सर
चलेगी अलग से अविनाश
यस यस
अरे पहले क्विज 1 2 3 होता था अभी बस 2 क्विज हो रहे क्यों ऐसा
हाँ देखता हूँ क्या आता है
ये सिलेबस चेंज हाँ
Anyone from Kshetra?
कहाँ से
हाँ सुजय
हाँ
हाँ बोला मैंने वो बात किया था वो जो था हम लोग का शायद डिप्लोमा में था उसके बाद हुआ था उसके बाद
तो सन्नी भाई बोलो
हाँ हाँ अरे यार
सन्नी भाई आजा व्हाट्सएप पे बात करते हैं
हाँ ठीक
Hello. Hello.